Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below.
Hello everyone. Today we're going to talk about AWS in 10 minutes. Let's look at the agenda here. Let's talk about what AWS is, why it's such a big hit. We'll have a look at the overview of the services. We'll see how much it costs, how big it is, and what the future of AWS is. So, what is AWS? Everyone is talking about Amazon Web Services, but let's have a look at what it is. It's basically a global cloud platform, which allows you to host and manage services on the internet. It's used by almost 80% of Fortune 500 companies to host their infrastructure, and it has a lot of services which it provides to its customers. There's infrastructure service, which means they provide bare servers as a service, so you don't need to manage the backup and the power supply of the service. They provide platform of the service. You can get Java, Ruby, PHP as a service, so that you don't have to manage the binaries of these applications. You get software as a service, wherein you get email sending capabilities like SES. You get queuing services like SQS, and it's a cloud storage platform wherein you have a lot of storage options including EBS and S3. So all in all, AWS is a hosting provider, which gives you a lot of services, wherein you can run your applications on the cloud. Now, let's take a look at why it's such a big hit. So everyone is trying to use AWS. Everyone is trying to put their applications on the cloud. So what's the reason that AWS is the top provider and the top choice for doing anything on the cloud? One of the biggest reasons is the billing. So the billing is very clear. You get a per hour billing. Every instance or every service has a micro billing. So, be it instances on EC2, you get per hour billing rate, which is very transparent. Even S3 buckets are charged on a per GB basis, although it is a storage service, but still, there is micro billing available there. The sign-up process is easy. You don't need to sign any agreement, nothing. You just go, sign up with an email ID, add a credit card, and you're good to go. You can go from 0 to 100 in just 2 minutes. You can launch your servers, big machines, without buying hardware. Without procuring any hardware, you can just be up and running in minutes. So, their billing dashboard is also very simple. They give you an integrated billing dashboard, which gives you reports. You can pull out reports every month. You can pull out reports based on services, based on various parameters. For the cloud provider to be a hit, you need it to be stable. It has to be a trusted thing. So their services are quite stable. In the last 7 or 8 years, they have seen some 3 or 4 major outages, but those have been only region specific. So that means out of the 12 or 13 regions in which they operate, the outages have been region specific in a particular country or continent. And those also have not been more than 2 or 3 hours and have not affected all of their customers. It's a trusted vendor. So when we talk about AWS, it comes up as something which is used by everyone in the industry. From small startups to big enterprises, everyone sees Amazon as a trusted advisor. Now, let's have an overview of the most commonly used services. So the first and the most commonly used service is EC2, which is Elastic Compute Cloud. This is the service which gives you bare servers. So this service will give you a machine which you can launch and you can run your software on those. You can get small or big machines based on your requirements. The second choice is VPC. So Amazon will not allow you full control of their cloud. Instead, they give you chunks of their cloud, which is VPC, or the Virtual Private Cloud. So VPC lets you create networks in the cloud and then run your servers in those networks. The next one is S3, which is Simple Storage Service. So S3 gives you the opportunity to upload and share files. So it is mostly a file storage and sharing service. Then you've got RDS, which is Relational Database Service. So this RDS allows you to run and manage databases on the cloud. So they've got almost all the major flavors of databases, right from SQL Server to Oracle and MySQL, PostgreSQL. They have recently launched another one, which is called Aurora, which claims to be a very high-performance database. Then Route 53 is there for DNS. So they've got a managed DNS service wherein you can point your DNS to Amazon and they take care of the stuff. So it's a global DNS service, it's a scalable DNS service, so it scales according to demand. There's also Elastic Load Balancer. The ELB is a service which gives you the opportunity to load balance incoming traffic to multiple machines. So this way, you can scale up your web applications to any number of users. You've got Auto Scaling, which adds capacity on the fly to Elastic Load Balancers, so that your website or your application is never down due to a load. How much does it cost? This per hour billing is already mentioned for everything. If it's something like a storage thing, again, there's a per hour or per GB month storage. So I think there is region-specific pricing. So Virginia is the cheapest region out of all of them. So the region-specific pricing is because they have got some regions which they have got good hold of, and they are the headquarters. So Oregon and Virginia are the cheapest actually. They also give you services based on the term. So if you sign up for something for a year, it would be cheaper for you rather than signing up for something on an on-demand basis. So they've got reserved instances which are very cheap as compared to the on-demand ones. You can get discounts from 20% to almost 60% if you sign up for a 3-year term. They are spot resources. Examples of these are spot instances. So this is like a bidding market base, where you can bid for a price. The only downside of this kind of pricing is that your machine might be terminated or your resources might be terminated if someone bids higher. People use these kind of things for doing some ad hoc in-search or some ad hoc tasks, which are really not critical. How big is it? They have got 15 regions across major countries of the world. They've got regions in the US, Europe, Asia Pacific. They've got a global footprint. So in today's world, if you are anywhere in the world, you would have a region within 1,000 miles of your location. They've got massive data centers. So each of the region has got multiple availability zones. So one availability zone can be thought of as a big data center. The data centers have anywhere from 300,000 to 500,000 servers. What is the future of AWS? So they currently have 64 services, which span across infrastructural service, software as a service, platform as a service. They are launching new services in all demands every day. Right now, they are focusing on machine learning. So recently, they've launched a couple of services, which focus exclusively on machine learning. And they are focusing on software as a service product, wherein they want to take control of the service you want to utilize. They don't want you to do it. They want you to upload it to them. And every now and then, they keep on reducing the costs. So you would hear it in the blog that, okay, the price of Ec2 machines has been reduced. And this is because of their scale. So they scale up and they give the cost benefit to the customer.
Today we will be discussing all about AWS and its impact in 2021. So let's get started. According to O'Reilly, more than 90% of organizations are expected to increase their cloud infrastructure. In 2021, the upshot is that the majority of cloud users plan to scale their business in cloud rather than reducing their cloud usage share. The COVID-19 pandemic led organizations to increasingly shift to the cloud, which helped them improve business continuity. Official meetings like video conferencing were done on the cloud using apps as Google Meet, Zoom, etc. Now let me give you a brief description on what cloud computing is. Cloud computing helps users to store, access, and manage data by logging in from their devices via the internet. Instead of storing data on their hard drives, cloud computing gives the ability to manage applications and services through the internet. Let's see what Gartner says about cloud infrastructure and platform services. For your information, Gartner is the famous IT service management company across the world. Gartner's Magic Quadrant report for cloud infrastructure and platform services noted that the capability gap between hyperscale cloud providers has begun to narrow. However, fierce competition for enterprise workloads extends to secondary markets worldwide. The famous cloud providers in the market are AWS, Microsoft Azure, and Google Cloud, all of which have been strong. AWS or Amazon Web Services has been known for its rapid pace of innovation in cloud computing, and this year is no different. AWS is the leader in public cloud providers and has a more significant impact on modern technologies like machine learning, robotics, and IoT. Amazon Web Services is an online service provider that offers various services such as compute power, storage, database, content delivery, and other resources to help businesses scale and grow. These services are provided based on a subscription basis. Talking about the general features, Amazon Web Services was founded in the year 2006, and apparently it holds a market share of 31.7%. AWS provides approximately 175 fully featured services. It consists of significant benefits like compute, storage, databases, networking, analytics, robotics, machine learning, artificial intelligence, etc. Now, let us know the 5 primary reasons why AWS is essential and how it can influence your business. Amazon Web Services has various benefits that make users rely on them. Firstly, it allows you to set up a virtual office, which will reduce the cost of maintaining and monitoring your infrastructure. Secondly, compared to the on-premises environment, AWS provides a high level of data protection and a lower cost to its users. Thirdly, based on the requirement you receive, you can scale up or scale down your resources. Fourthly, in case you face a power failure or any crisis, having your file stored in the cloud ensures it is backed up and secured in a safe location. And lastly, in short, AWS offers high scalable services for database, data warehousing, transcoding, storage, backup, infrastructure management, application management, etc., which helps in reducing the overall time and effort spent in setting up and managing the infrastructure. Now, let's take a step back and look at the history of AWS. Amazon Web Services was the first online service provider to introduce a pay-as-you-go pricing model in cloud computing. AWS was launched in 2006 with 3 services: Amazon EC2, AWS S3 Cloud Storage, and SQS. Now, let us discuss how much the companies have saved with the help of AWS. This shows a tremendous benefit of using AWS. AWS continues to lower the cost of the cloud for its customers. Compared to on-premise infrastructure, when a web application is deployed on AWS, companies save 76% of the total expense. Companies save over 50% by running business applications by consuming AWS resources. AWS is the world's most broadly adopted cloud platform. Many companies like ESPN, Adobe, Twitter, Netflix, Facebook, BBC, etc. use AWS. Adobe quickly creates and updates software without depending upon the IT teams. It utilizes its services by offering multi-terabyte operating environments for its clients. By deploying its services with Amazon, Adobe integrated and operated its software in a simple manner. A lot of people don't know the reason for AWS being so popular. To understand the popularity of AWS, you need to look at these numbers first. First is cost. AWS costs keep declining. AWS has decreased its service price as many as 60 times since its launch. AWS saves 76% of the expenditure of running a standard web application and reduces the processing cost by 50%. 1/3 of people who visit websites on a daily basis access sites powered by AWS. AWS has customers over 190 countries worldwide, including 5,000 edtech institutions and 2,000 government organizations. 31% of cloud infrastructure as a market share service belongs to AWS, while 10% belongs to Microsoft and 7% to IBM. AWS has more than 1 million users in 190 countries. Now, let's discuss the revenue growth of AWS. According to Gartner, Amazon retained the number one position in the IaaS market in 2019, followed by Microsoft and Google. Amazon continued to stay on top of the IaaS market worldwide with an estimated $20 billion of revenue in 2019 and $96.1 billion in 2020. As of February report, Canalys confirms AWS has a total market share of 31%, whereas Microsoft holds a share up to 20%. Microsoft maintained number 2 position in the IaaS platform with more than half of its nearly $8 billion in revenue. According to the Canalys diagram shown on your screen, Amazon leveraged its number 1 position in the cloud market continuously from 2019 to 2020 by offering complete and unique services in the cloud stack. In Q2 2020, a prediction of profit in AWS was expected to reach $88.9 billion, but surprisingly, due to COVID-19, the company saw quarterly sales increase to $88.9 billion. The net income of $5.2 billion was the highest in a single quarter, while Microsoft Azure has seen revenue growth of 47% over the previous quarter. The report has a revenue growth number of various cloud providers. AWS is continuously adding new features to utilize the updated services to improve the productivity of work more quickly. Let's discuss each service one by one. At number 1, Amazon Cloudfront supports Origin Shield. Amazon has updated its Cloudfront service with a Shield feature that increases cache capacity and decreases the load on your Origin. Next, AWS IAM supports AWS Private Link, which means it can invoke Lambda functions into a virtual private cloud by eliminating network traffic to the public internet. Thirdly, Amazon SNS supports FIFO in sequence. Amazon SNS introduces first-in, first-out topics intended for customers to process messages across multiple services in a sequenced manner. Amazon SNS FIFO is available in 22 AWS regions. Next, AWS DMS functionality supports Amazon Document DB. Amazon Document DB has the responsibility of storing, querying, and indexing data with AWS Database Migration Service support. DMS helps in migrating databases to AWS environments quickly. Next, Amazon Chime SDK now supports health monitoring and troubleshooting. Developers can now collect client metrics from meeting events available from the Amazon Chime SDK for JavaScript. Finally, AWS Server Migration Service now adds support for application monitoring using Amazon CloudWatch Application Insights. You can start monitoring applications in Amazon CloudWatch as soon as the application migration is complete in AWS SMS. There are plenty of cloud jobs that can help you grow in your career. Tech Republic says in the past few months, job seekers are hunting for cloud computing roles on Indeed website. Cloud computing job roles such as cloud infrastructure, cloud security, cloud architect, and cloud engineer had risen nearly by 108%. Employer interest for candidates with cloud computing skills rose by 33%. Now let's look at who an AWS Solutions Architect is and what they do. An AWS Solutions Architect is responsible for deploying your applications on the AWS platform. Ever since cloud computing has come into the limelight, companies and organizations worldwide have started to migrate their physical infrastructure to the cloud. This is where AWS Solutions Architects come in. They help in relocating the physical infrastructure to the AWS cloud. AWS Solutions Architect is responsible for creating a design with a detailed blueprint of the cloud infrastructure they plan to set up. They are required to focus on non-functional requirements such as usability, reliability, scalability, and cloud infrastructure performance. AWS Solutions Architects are responsible for minimizing business risks such as security leaks, calculation mistakes, and even application downtime risks. Every AWS Solutions Architect must ensure that none of these problems happen. A lot of people must be wondering how much a solution architect and a cloud engineer earns. The average salary of a solution architect in India is Rs 18,36,996 per year, and in the United States they earn $128,000 per annum. Whereas a cloud engineer in India earns 12,41,000 rupees per annum, and in the United States they earn $139,440 per annum. Now that you know about AWS and its important concepts, time for a small quiz. Which of the following is an online backup and storage system? Option A, Amazon Simple Storage System, AWS S3. Option B, AWS CloudFormation. Option C, Amazon Elastic Compute Cloud, AWS EC2, and option D, both A and C. Let us know what you think is the right answer in the comments below.
In cloud computing, the competition for leadership is quite a tough three-way race. Amazon Web Services, Microsoft Azure, and Google Cloud Platform clearly are the top cloud companies, hold a commanding lead in the infrastructure as a service and platform as a service markets. In this video, we will compare and contrast AWS, Azure, and GCP based on a few related concepts around these cloud computing platforms. It will help us understand the functioning of these top cloud platforms and will also let us figure out the individuality of each one of them. But before starting with the comparison, let's have a quick introduction of AWS versus Azure versus GCP. So let's get started. Amazon Web Services, or AWS, is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on site for businesses and individuals. These resources are available for free or for a fee per usage. Microsoft Azure is a cloud computing service that it offers a collection of cloud computing services for building, testing, deploying, and managing applications in the cloud, including remotely hosted and managed versions of Microsoft technology. Google Cloud Platform offers a variety of cloud computing services for building, deploying, scaling, monitoring, and operating a cloud. The services are identical to those that power Google products such as Google Search, Gmail, YouTube, and Google Drive. Now let's move on to the comparison between AWS, Azure, and GCP. We will be comparing them based on few major parameters like origin, service integration, availability zone, cloud tools like compute, storage, networking, market share, pricing, and at last, who uses them. Now, let's move ahead and start with the first comparison, origin. In the year 2006, Amazon Web Services, AWS, was introduced to the market, and in the year 2010, Azure launched its services. Whereas on the other hand, GCP was established in the year 2008. From the start, AWS has been supportive of the open source concept, but the open source community has a tense relationship with Azure. On the other hand, GCP, similar to AWS, provides Google Cloud with managed open source services that are tightly linked. AWS offers services on a large and complex scale that can be manipulated, but Azure support is comparatively low quality, whereas GCP's monthly support price is almost $150 for the Silver class, which is the most basic of services and is quite expensive. Now let's move on to the service integration of these cloud platforms. Service integration is a set of tools and technology that connects different applications, systems, repositories, and data and process interchange in real time. AWS makes it simple for users to combine services such as Amazon EC2, Amazon S3, Beanstalk, and others. On the other hand, Azure allows customers to effortlessly combine Azure VMs, Azure App Service, SQL databases, and other services. Whereas users can utilize GCP to combine services such as Compute Engine, Cloud Storage, and Cloud SQL. Now that we know briefly about all these cloud platforms, let's have a look at the availability zones of these platforms. Because AWS was the first in the cloud domain, they have had more time to build and extend their network. But Azure and GCP both have various locations around the world. But the distinction is in the amount of availability zones they have. AWS now offers 66 availability zones with an additional 12 on the pipeline. Close to it, Azure is available in 140 countries and is available in 54 regions throughout the world. But Google Cloud Platform is now available in 20 global areas, with 3 more on the way. Now let's move on to the next important factor, which is tools. Now let's move ahead and have a look at the first feature, which is compute. Elastic Compute Cloud, or EC2, is AWS Compute Service, which offers a wide range of features, including a large number of instances, support for both Windows and Linux, high-performance computing, and more. Azure, on the other hand, virtual machines, is Microsoft Azure's core cloud-based compute solution. It includes Linux, Windows Server, and other operating systems, as well as better security and Microsoft program integration. In comparison to its competitors, Google's computing services catalog is somewhat smaller. Compute Engine, that company's principal service, offers custom and predefined machine types, per second invoicing, Linux and Windows support, and carbon neutral infrastructure that uses half the energy of traditional data centers. Within the compute category, Amazon's different containers services are gaining prominence. It has Docker Kubernetes, and it's also Fargate service, which automates server and cluster management when using containers as well as other alternatives. Azure, unlike AWS, uses virtual machine scale sets of 2 container services. Azure Container Service is based on Kubernetes, and Container Service uses Docker Hub and Azure Container Registry for management. For enterprises interested in deploying containers, Google offers the Kubernetes engine. It's also worth noting that Google was significantly involved in the Kubernetes project, providing it extensive knowledge in this field. Now let's move on to the next parameter of comparison, which is storage. Simple Storage Service for object storage, Elastic Block Storage for persistent block storage, and Elastic File System for file storage are among AWS storage offerings. Blob storage for REST-based object storage of unstructured data, queue storage for a large volume workloads, file storage and disk storage are among Microsoft Azure's core storage services. GCP offers an increasing number of storage options. Its unified object storage service, cloud storage, also has a persistent disk option. Relational Database Service, or RDS, DynamoDB, NoSQL Database, Elasticache in-memory data store, Redshift data warehouse, Neptune Graph Database, and Database Migration Service are all SQL-compatible databases offered by Amazon. The database choices in Azure are especially wide. SQL Database, MySQL Database, and PostgreSQL Database are the 3 SQL-based choices. When it comes to databases, GCP offers the SQL-based Cloud SQL and Cloud Spanner, a relational database built for mission-critical workloads. Now the next parameter is networking. AWS uses Amazon Virtual Private Cloud, or VPC. On the other hand, Azure uses Azure Virtual Network, VNet, and GCP uses Cloud Virtual Network. Now let's move on to another factor, which is market share and pricing. All these cloud services are based on comparative pricing strategy, which means you need to pay on the basis of its usage. According to Canalys, the worldwide cloud market rose 35% to $41.8 billion in the first quarter of 2021. AWS accounts for 32% of the market, with Azure accounting for 19% and Google accounting for 7%. On one hand, Amazon charges on a yearly basis, and on the other hand, Microsoft Azure and Google services charge on a minute basis, and also of them provide you a standard price for you to access these services. AWS charges roughly $69 per month for a very basic instance with 2 virtual CPUs and 8 GB of RAM, and AWS largest instance with 3.84 TB of RAM and 128 vCPUs will set you back roughly $3.97 per hour. But in Azure, the same type of instance One with 2 vCPUs and 8 GB of RAM costs roughly $70 US per month, and Azure's largest instance has 3.89 TB of RAM and 128 virtual CPUs. It costs about $6.79 per hour. Compared to AWS, GCP will supply you with the most basic instance, which includes 2 virtual CPUs and 8 GB of RAM for 25% less. As a result, it will set you back roughly to $52 every month, and the largest instance that includes is 3.75 TB of RAM and 160 vCPUs. It will cost you around $5.32 per hour. Amazon, other than this, also provides spot instances, reserved instances, and dedicated hosts where you can look for multiple offers and discounts. But for Azure, it provides special prices to developers based on situations, or even Azure Hybrid Benefit, which benefits your organization up to 40% if it uses Microsoft software in their data centers. Whereas Google offers quite assorted pricing to its customer compared to other two. It gives you sustained use discounts, which activate if you use the same instance for a month. The printable instance, which is very similar to Amazon Spot instances. But one thing is common in all the three cloud services, which is they all offer long-term discount. Now let's have a look at the last comparison, which is companies using them. Because AWS is the oldest player in the cloud business, it has the largest user base and community support. As a result, AWS has the largest number of high-profile and well-known clients including Netflix, Airbnb, Unilever, BMW, Samsung, MI, Senga, and others. With time, Azure is getting a large number of high-profile customers. Azure currently boasts around 80% of Fortune 500 firms as customers. Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, and others are among its key clients. Google Cloud, on the other hand, uses the same infrastructure as Google Search and YouTube, and as a result, many high-end enterprises trust Google Cloud. HSBC, PayPal, 20th Century Fox, Bloomberg, Domino's, and others are among Google Cloud's many clients. So, this was all about AWS versus Azure versus GCP.
Hi there, welcome to this brand new learning video called Cloud Computing Tutorial. I'm Samuel, a multi-platform cloud architect and trainer working for Simplilearn. Let's dive deep into the topics we're going to discuss here. Why we needed cloud computing to begin with, and what is cloud computing and different types of cloud computings available at the moment. And we also are going to talk about dominant cloud providers available in the market at the moment. And we will touch a few topics or scenarios on life cycle of a cloud computing solution. And we will be talking about how cloud computing is implemented in AWS. And there's nothing like visually seeing how things work in the cloud, right? So we're going to end it with a demo, and we're going to talk about products, or we're actually going to use products like EC2 and S3, EC2 being a virtual computer in the cloud and S3 being an object storage in the cloud. Let's understand about why cloud computing was needed. What was the problem that we had that cloud computing solved, and since then it took over the market. Let's answer a lot of unanswered questions about cloud computing or services that you might have. Here on the left, we have an owner of a business, and he wants to set up an DZ or have an IT infrastructure for his company. So he called Paul, an IT educated person in his company, and consulted him about how to go about setting up an IT infrastructure. Now, Paul is the kind of guy who keeps himself updated about what's happening in the IT industry, and he frequently goes through learnings about the recent technology. So with the benefit thing, I'm going to explain to you now. Let's start with the expenditure or the billing model. Expect that we pay everything upfront, and there is an additional operating cost, and it never lets us to dynamically scale. In on-premises, a lot of space is required for seating the servers, but in the cloud, not such space requirement is needed for the organization. In on-premises, we also need a dedicated team to manage the hardware and software, but in the cloud, no such dedicated team is needed for most of the services. They all get managed by the provider. And even if we need to manage them, the provider gives us options to manage them through the console, which is lot simpler than managing directly from the device. In the on-premises, we need to admit the fact that data security is poor due to the cost involved in procuring the hardware and software to provide the security. But in the cloud, the security standards are high due to the investments the providers have done to secure the data and to meet the compliance. In traditional DC, there will generally be less focus on data recovery, and we kind of settle for less when it comes to data recovery due to the cost involved and the effort involved in replicating the data. And even if we set up a high performing data replication, a lot more can be done in the cloud for the same cost. The on-premises environment lacks the flexibility needed today. Like if I need to restructure the IT for the new age business needs, then the on-premises is not so friendly for such changes. But in the cloud, I can easily undo or tear down an environment or migrate to the new environment and tear down the old environment in few button clicks. Now, looking at the number and the frequency of the releases that happen, scheduling updates would be a full-time job. But with cloud, the updates happen automatically. In on-premises, if I'm working with a team that is spread across the globe, working with them in unison and sharing the data is a tedious work. But with the cloud, there are a lot of tools and technologies put together that makes it easy to share the data with other members in the team or with the new prospective customer. In on-premises, if I'm working with a team that is spread across the globe, working with them in unison and sharing the data is a tedious work. But with the cloud, there are a lot of tools and technologies put together that makes it easy to share the data with other members in the team or with a new prospect customer I will be working with who is present across the other side of the globe. In on-premises, the data will be present inside the DC or inside the on-premises DC, and even a valid user trying to access the data from outside the organization is a tough task. But with the cloud, as long as someone has internet, providing the person access is just a few mouse clicks away. Talk about implementation. Building an on-premises DC takes time. I was working on a project a few years back, and the goal to make a DC go live at that time was after 2 years from the date we were speaking about it. But with the cloud, we can bring our DC in the cloud within weeks. After all this explanation and comparisons and talking about benefits, Paul's manager was fully enlightened and wants to have his IT environment in the cloud. But our Paul is not done yet, and he took his manager through another level of discussion about the cloud, just like I'm going to take you now. So let's talk about what is cloud computing. Now, cloud computing is the ability to deliver on-demand computing service over the internet, and that too on a pay-as-you-go basis. Now, you might think, well, what does that mean? Let me explain. Now, with cloud, rather than managing files on local storage devices, cloud computing makes it possible to save them over the internet and access them from the internet. So I can be a mobile person, moving from place to place, but I can access the storage from the internet because it's in the internet. And if I want to give access to somebody else, again, it's easy for me to give access to them as long as they have internet connection available with them. Now let's move further and talk about or get understanding on the types of cloud computing. We can categorize the different types of cloud computing based on two wide categories, one being a deployment model and the other one being service model. Let's talk about the deployment model first. Deployment model is categorized into three types. First one is public, and then private, and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. It'll be easy for me to explain, and also it'll be easy for you to understand if I walk you through this example. Consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resource that I use, and I pay for how long I use it. If I use less, I pay less. If I use more, I pay more for that month. Simple. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here, I pay a huge amount upfront and it is all owned only by me. I do not pay for it in an hourly fashion, but completely and all upfront. The cost here is very huge. And thirdly, if I want the best of both types, like the comfort of the own car and still don't want to pay all upfront, otherwise want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in a hybrid environment, meaning if I already have a DC, I can integrate it with the cloud and use both the DCs, and that would become an hybrid environment. Alright, so that was good of an learning. Let's summarize the types of cloud based on deployment models. And as we know now about the public cloud is an cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players as cloud providers are AWS, Microsoft Azure, IBM's Blue Cloud, and Sun Cloud. And private cloud? Now this cloud infrastructure is exclusively operated by a single organization. It can be managed by organizations or third party and may exist on premises or off premises, doesn't matter, but the point here is this is exclusively operated for a single organization. And some companies that provide private cloud are AWS and VMware. And hybrid cloud gives the best of both public and the private cloud. For example, the federal agencies, they opt for private clouds for storing and developing personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments. Now let's talk about different clouds based on the service model. If we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, or platform as a service, PaaS, or software as a service, SaaS. They sometimes are referred to as IaaS, PaaS, and SaaS. Now at this moment you could be like this guy thinking, Sam, I thought you're done categorizing the cloud. Now you're going to talk about 3 more categories? Which one should I pick? Well, let me explain. If all that you want is just a VM and you have all the expertise to install the software on top of it and make it work, then go for IaaS. If you only want a platform or an interface to program or an interface to upload a program and make it run, then pick PaaS. Or if all that you want is a finished product hosted in the cloud and be able to access it through the internet, then go for SaaS. Here you get a username and password for an application and you can begin to customize the application based on your needs. Alright, let's talk about IaaS in a bit more detail. IaaS, it gives basic computing infra. It's based on a pay for what you use model. And some of the cloud providers who are big players are AWS, Azure, and Google. And here the users generally will be IT admins. In PaaS, the provider gives you a platform or a runtime environment for developing, testing, and managing application. It's platform ready. You buy the platform, you upload your code, and you start working on it. And it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would use PaaS is software developers. And in SaaS, everything is managed by the vendor, be it the hardware or the software. It's managed by the vendor, and we pay for the service and we pay for it through a pay-as-you-go subscription model. And as you might have guessed, the end users here would be end customer itself. Alright, let's put together everything in the same page and compare and contrast the different types of service models. In this chart, it explains the difference between the 4 models, starting from on-premises to IaaS and then PaaS and SaaS. It is self-explanatory that the resources managed by us are huge in on-premises and little less in IaaS, and further less or reduced in PaaS, and nothing to manage when it comes to SaaS. Let me also explain the different types of cloud services through an example like this. Let's say that you have a crush on cake and you're planning to bake one yourself. Now let's look at the options you can have. You can make all the ingredients yourself, be it the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, the needed water, and the rest. You get an idea, right? Everything is yours, and that's on premises. All that you use is owned by you and nothing is managed by the vendor. The other options you can have is buy the ingredients and mix and bake the cake yourself. Now this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service is a shared responsibility. The other options you still have on hand is simply pick a phone and order a cake. Now this is a lot simpler than the rest we discussed so far. It's simply picking the phone and ordering the cake and pay for it when it arrives. Simple. And when it reaches home, you will have to arrange the table, garnish the cake if that's needed, and then enjoy the cake. It's the same way with PaaS. Just get the platform in which you would run your code and upload your code and start running your application. Here you and the vendor still share the responsibility. You still have one more option left, that is simply go out and dine. This is a lot simpler, that it requires no effort from us at all. You buy the fully finished and garnished cake and pay for it and walk out. No responsibility on making the cake. It's the same way with SaaS. We buy the finished product and pay for the finished application. As next thing, let's talk about the different cloud providers. Amazon Web Services, AWS, is a cloud computing service provided by Amazon. It provides a mix of infrastructure as a service, IaaS, platform as a service, PaaS, and packaged software as a service called SaaS offerings. Microsoft Azure, formerly known as Windows Azure, is a cloud computing service by Microsoft, and it sort of specializes in using cloud for building, testing, deploying, and managing the applications through the servers throughout a global network that Microsoft manages. It also provides software as a service, platform as a service, infrastructure as a service, and it supports lots of different programming languages and tools and frameworks, including both Microsoft and third-party software and systems. IBM Cloud is a cloud computing service offered by IBM. IBM Cloud includes infrastructure as a service, software as a service, platform as a service. Now, the difference is here it offers through public, private, and hybrid cloud delivery models. VMware, on the other hand, is a subsidiary of Dell Technologies and provides cloud computing and platform virtualization software and services. It was the first commercially successful company to virtualize the x86 architecture. Google Cloud Platform, on the other hand, is offered by Google. It's a suite of cloud computing services that run on the same infrastructure that Google uses internally for its end-user products such as the Google search and the YouTube we are familiar with. Alongside a set of managed tools, it also provides cloud services including computing services, data storage services, data analytics, and machine learning services. DigitalOcean, on the other hand, is headquartered in New York City with data centers worldwide. DigitalOcean provides developers cloud services that help to deploy and scale applications that run simultaneously on multiple computers. As of January 2018, DigitalOcean was the third largest hosting company in the world in terms of web-facing computers. Let's talk about cloud computing in AWS. Amazon Web Services, AWS, is a cloud computing service provided by Amazon, and these services are accessible over the internet. And because AWS provides infrastructure as a service, it's a flagship offering, we can create and deploy any type of application in the cloud on top of the IaaS that Amazon provides. And the best part here is the subscriptions are pay-as-you-go type. You use less and pay less, and only for what you have used. You use more, pay more, but still less per unit for the service used. Attractive, isn't it? Now let's talk about the life cycle of the cloud computing solution. The very first thing in the life cycle of a solution or a cloud solution is to get a proper understanding of the requirement. I didn't say get the requirement, but said get a proper understanding of the requirement. It is very vital because only then we will be able to properly pick the right service offered by the provider. Getting a sound understanding, the next thing would be to define the hardware. Meaning choose the compute service that will provide the right support where you can resize the compute capacity in the cloud to run application programs. Getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all. There are different services and hardwares for different needs you might have, like Ec2 if you're looking for IaaS, and Lambda if you're looking for serverless computing, and ECS that provides containerized service. So there are a lot of hardwares available. Pick the right hardware that suits your requirement. The third thing is to define the storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud or from the internet. And choose the appropriate storage. There is one separately for backup called S3, and there is one separately for archival, that's for Glacier. So you knowing the difference between them really helps in picking the right service for the right kind of need. Define the network that securely delivers data, video, and applications. Define and identify the network services properly. For example, VPC for network, Route 53 for DNS, and direct connection for private P2P line from your office to the AWS data center. Set up the right security services, IAM for authentication and authorization, and KMS for data encryption at rest. So there are a variety of security products available. We got to pick the right one that suits our need. And there are a variety of deployment and automation and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, Auto Scaling is for being elastic, and CloudFormation is define the management process and tools. You can have complete control of your cloud environment if you define the management tools which monitors your AWS resources and or the custom applications running on AWS platform. There are a variety of deployment, automation, and monitoring tools you can pick from, like CloudWatch for monitoring, Auto Scaling for automation, and CloudFormation for deployment. So knowing them will help you in defining the lifecycle of the cloud computing solution properly. And similarly, there are a lot of tools for testing a process like CodeStar and Code Build and Code Pipeline. These are tools with which you can build, test, and deploy your code quickly. And finally, once everything is said and done, pick the analytics service for analyzing and visualizing the data using the analytics services, where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Athena, and other tools for analytics are EMR, and which is Elastic MapReduce, and Cloud Search. Alright, enough of theory, and let's have a quick look at how two services in AWS, EC2 and S3, work together and benefits us. Here are two IT professionals talking to each other. One says, I have an application which takes a lot of storage and works only on Linux system, which I do not have at the moment. And the other one is a smart guy, and he immediately replies that he could use S3 to store data and retrieve data, and use EC2 for all his compute needs. And then the curious conversation builds up, and the first person wants to know what is EC2 and S3. And the second guy starts to explain that AWS EC2 is a web service that provides a secure and resizable compute capacity in their cloud. And EC2, it can also be used to launch as many virtual servers as we need. And about S3, he explains AWS S3 is a simple storage service provided by AWS. And about S3, he explains further, saying that using Amazon S3, we can store and retrieve any amount of data at any time on the web. Alright, so the very first thing is to have an AWS account. So create an AWS account. And second thing is to create an AWS S3 bucket and upload the files there. The files that EC2 server is going to pull from will get stored in S3 as first thing. Alright, so the first thing is to create an S3 bucket. So let's create an S3 bucket and let's call it as website bucket. And these names will have to be unique. So let's see if this bucket name is available. It says bucket name already taken or already exist. So let me top it up with SL, meaning Simplilearn. Alright, so we were able to create a bucket, and in that bucket let me upload a content. That basically is going to be my index file that's going to go and sit in my web server. So let me also make it public and view it. Alright, so this is the content that I have stored in my S3, and this is the content I'm going to push to my EC2 server. Alright, second step, create an AWS S3 bucket and upload files. We're done with that. Third is to create an EC2 instance. That's, in other words, create an virtual machine in the cloud. Let's go and create it. Alright, the third thing is to create an EC2 instance. So let's create an EC2 instance. It's plain and it's very simple. I'm going to keep everything as defaults here. Alright, so I've launched an EC2 instance. As you see, it's running. I also have an IP address, public IP address here. With that, I have logged into this EC2 instance, and I'm in the folder /var/www/html, and as you see, there is nothing in there at the moment. And this server also has Apache installed in it. As you can see, I browsed to the IP address of the EC2 instance, and it's showing a page which is the default Apache page. Alright, if I had any files in this folder, that would get shown as the web page instead of the default page. Our task is to save files in S3 and move them to the EC2 instance. So S3 is going to act as a storage or a repository or a source code control in this example. Alright, so let's do that. Alright, the third step is to create your EC2 instance, and that's what we have done. And the EC2 instance has no files in it. And the fourth step is to synchronize the source code bucket with the EC2 instance. Let's do that. The actual command to do that would be AWS S3 sync, and then the name of the bucket from which we're going to pull the code, and the folder in which we're going to put the code or the data. Alright, so it has downloaded something. Look at that. And now if we go back to the test page and do a refresh, there you go. It's showing the page that it pulled from S3. So here I can use S3 as the source code control bucket, and any information that I put in there will get reflected in EC2 instance once I do a sync every day. And that's how I use S3 as my storage for EC2. Alright, finally we were able to synchronize S3 bucket and the EC2 instance. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital costs. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries. Using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service, Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL or American Online uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses Ec2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon Cloudfront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS And if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data, and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 Instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing, and now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? Alright, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. Alright, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. And let me help you understand about AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed a few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the software's and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the Ec2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. Or what kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my Ec2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of Ec2 instance, and it protects that Ec2 instance from unintended inbound and outbound outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY Gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is ec2-user, and this is the default, by the way. Let's put the username ec2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2, so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. Let me welcome you to this new video learning where we're going to learn about Lambda, and I'm very glad that you're watching this AWS Lambda tutorial now. One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling and environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda, and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda, and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides. Along with EC2, EBS, Elastic Load Balancer, Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. all we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon web services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. a near real-time manual backups. That's what the business demands, but that's not near real-time backup, that too a manual one. That's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient, looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. All right, go to services, go to S3, source bucket. All right, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. All right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name, and then create a role. Now I have a role created as well. Right, copy lambda, and that's having the policy that we have created sometime back. Now create a lambda function. Right, so go to lambda, create a function give it a name like S3 bucket copy. All right, choose the role that we want to use. All right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now, what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory those data should be present in the destination bucket as well. There you go. It's all done by Lambda. And I'm going to be touring you with different S3 features and technical details in this section. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3, and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our Ec2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment and also want to keep a copy of the data locally, so users locally can access them and cloud users or internet users can access the data from the cloud. If that's your requirement, then Storage Gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling Snowmobile. Snowmobile is not available in all the regions. Alright, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion here, one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is Simple Storage Service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability, meaning durability is if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. All right, so let's talk about the benefits of S3. S3 is durable, as we saw. It provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you would be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows, and what we would use in the run command prompt in the PowerShell. All right, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it a JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to Services under Storage, and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simplylearn.samuel.com, and I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions Amazon provides S3 service. You know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to read write as well? stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now, over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, get the data flushed out of your account automatically? Those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. All right, so let's take this example, and there are different storage options in S3. Let's take S3 standard, for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly, something like students attendance report or students attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis. But if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. Welcome to this new learning series called IAM, a service in AWS for security. Here in this section, we're going to talk about what is security in AWS and then we're going to slowly or gradually move on to the other topics like types of security available in AWS. Out of all the services, why IAM is the most preferred one, and then we're going to talk about what is IAM in general, how it works, the building blocks or components in IAM, and the features, the attractive features that it provides that makes IAM stand out from the rest of the services available. We're going to talk about that, and then we're going to end today's session with a demo about how IAM gets well interacted with other services in Amazon and help create a secure environment in the cloud. Let's talk about AWS security. Now, cloud security is the highest priority in AWS. And when we host our environment in the cloud, we can be rest assured that we are hosting our environment in a data center or in a network architecture that's really built to meet the requirement of the most security sensitive organization. And this high level of security is available to us on a pay-as-you-go type, meaning there is really no upfront cost that we need to pay. And the cost for using the service is a lot cheaper than what it is in an on-premises environment. So AWS Cloud provides a secure virtual platform where we can deploy our application. Now, compared to the on-premises, when using or attaching that type of security to our application is very low compared to on-premises. There's really no upfront cost, and the cost is very lower. Whatever cost that we pay is very lower than what it would be in on-premises, and all this contributes to the secure environment we can get through IAM in AWS Cloud. There are really many types of security services available in AWS. To name a few, or to name the familiar ones, IAM stands first, followed by Key Management System, KMS, and then we have Cognito, that's another service, and Web Access Firewall, WAF, is another security service in AWS. Now let's start our discussion by talking about IAM, and that's what this whole series is about. Now, IAM, or Identity and Access Management, it really enables us to manage access to AWS services and AWS resources in a very secure manner. With IAM, we can create groups. We can actually allow those users or groups to access some service, or we can sort of deny them to access the service, whichever we want. That's all possible through identity and access management. And this feature comes with no additional charge. Now let's talk about how things were before AWS. Before AWS, or before IAM in general, it was not that safe in a corporate to share the password over the phone or through the email. That was the practice that was existed at that time. Now, we all can remember the days when we need to switch to a different account, or we had just one admin password commonly stored in a location, or one person would reset it and maintain it, and anytime or we need to log in, we call the person, ask for the admin password over the phone, and then we try logging in. Now, that was not secure at all back then. Somebody could walk by and sort of eavesdrop, get the password. Now they walk away with the password with them. So they're all possible when we share the password over the phone and through the internet or email. Now with AWS, a lot of options are available that I'm not sharing password over the unsecure medium. Now Slack is a third-party product available with AWS. It's not an AWS product, but Slack is a third-party application that's hosted on AWS. And it's really a communication tool that helps people to share documents. So now we're not sharing the password over the phone, rather through the applications, and no eavesdrop person can really catch the password and try it in their system to access our environment. That's not possible. So you see the difference now. Back then, sharing password was only through phone and email, and you would write it on a paper and you give it to somebody. But now technology is providing provisions enough for us to share the password in a secure way. We're still talking about IAM. IAM is an web service for securely controlling access to the AWS resource. Now it really helps us to authenticate or sort of limit access to a certain set of users accessing the AWS account or certain set of users accessing a certain set of resources in AWS account. Now you see this picture, we have an IAM administrator who's trying to allocate permissions to different group of people. So we have group 1 on the top and group 2 in the middle and group 3 towards the end. The administrator using IAM or IAM empowers the administrator, allow access to certain group to certain resources. That's what IAM is all about. Now let's talk about the building blocks, or let's talk about the elements that make and complete IAM. So the elements are categorized into 6 different elements. We have the principal in IAM, the authentication, the request, the actual request coming in, the authorization, allowing, denying access, actions, what are the scope of actions can be taken, and on what resource. Is it EC2, is it RDS, is it S3 bucket? So what resource these actions are applied to. So they are the basic elements of an IAM workflow. Let's talk about principal, for example. An action on AWS resource can only be performed by a principal. An individual user, they can be a principal. A role in AWS IAM, it can be a principal as well. In other words, a principal is an entity that can take an action on an AWS resource. You know, a principal can be an user, a principal can be a role, a principal can be an application that's trying to access the AWS environment. Secondly, authentication. Now, authentication is a process of confirming the identity of the principal trying to access the AWS environment. Now, how do we get authenticated, or how does a user get authenticated? By providing credentials or the required keys to validate that this is what he or she is as per what's in the record. So all principal must be authenticated, and we get authenticated using the username and password to log into the console. If it is CLI, or we get authenticated using the access key and the secret access key. The other component that makes up IAM is request. When a principal tries to use the AWS management console, what the principal is doing, or what the user is doing, is sending a request to the AWS environment. And the request will have the principal actually wants to perform. Is it an put request, or is it a get request, or is it a delete request, stuff like that. And it's also going to carry information about on which resource the action needs to be done. Is it on EC2 1? Is it on S3 bucket Simplilearn.com? Stuff like that. So it has a specific action that it wants to perform and the resource on which it wants to perform, and also some information about from where the request is originating from. Is it within an AWS environment, or is it with another cloud service provider, or is it with on-premises, stuff like that. So these information will be present in the request. Authorization. Now this IAM uses information from the request context to check for matching policies, and it takes a decision whether to allow or to deny the request. Now here it has a logic. By default, all the resources are denied, and IAM authorizes your request only if every part of the request is allowed by a matching policy. So there is an evaluation logic that says by default all requests are denied, and if there is an explicit allow, then it overrides the default deny. And if you are explicitly denying a service, then all the allow statements gets overridden, and all the other statements gets overwritten, and this explicit deny stands. By default, only the AWS account root user has access to all the resources in that account. So if you're not signed in as a root user, then we must be specifically granted permission through a policy. In other words, we need to be authorized through the policy. Now let's talk about action. Now after authenticating and authorizing the request, AWS approves the action that we are about to take. Now using action, we can view the content, we can create a content, or create a bucket, or create an EC2 instance. I can edit content, or even I can delete a resource. That's all based on the action that I'm allowed to do. Now that was about actions. Now where is the action performed? The action is performed on the resources. A set of actions can be performed on a resource, and anything that's not mentioned in the action, or anything that's not tagged with the action and the resource, they don't get to complete. For example, let's say if you attempt to delete an IAM role, and you also request to access the EC2 instance for that role, then the request gets denied. Now let's talk about some of the other components of IAM. So the other components of IAM are the basic building block is an user, and then many users together, they form a group. And then policies are the engines that allows or denies a connection. Based on policy, one gets to access or gets no access to a resource. And then roles are another component. Roles are temporary credentials, I would say, that can get assumed to an instance as and when needed. Right, let's talk about this component called user in an IAM. With IAM, we can securely manage access to AWS services, and we can create an IAM user anytime there is a new employee joining our corporate. So it's a one-to-one mapping. One user or one employee gets a username directly attached to them. And a username or a user is an account-specific thing. It's very local to that AWS account that we are using. So in detail, an IAM user is an entity that we create in an AWS environment to represent a person or a service that interacts with AWS environment. And this user is going to have some credentials attached to them. And by default, they do not have a password, and they do not have any access key or secret access key attached to them. In fact, literally no credentials of any kind. Now we must create an user, and we must create the type of credential that gets attached to the user. Do they want to access CLI? So based on that, we would be adding credentials to them. A user by default is not authorized to perform any action in AWS. And the advantage of having one-to-one user is that we can assign permissions individually to that user. For example, we might want to assign administrative permissions to few users who can administer our AWS environment, and users are entity within an AWS account. Users don't have to pay separately. They start using the servers, and that get bills under the account they are attached to. So separate users doesn't mean that separate payment for those users. They are just users in our account, and the whole account gets to pay for the resources that they provision. Again, the IAM user does not always represent a person. An IAM user is really just an identity with associated credential and permissions attached to it. It could be an actual person who's a user, and it could be an application also who is a user. Next, we'll talk about groups. Talking about groups or understanding group is very easy. A collection of user forms an IAM group, and we can use IAM group to specify permission for multiple users, so that any permission that's applied to the group is also applied to the users who are add to that group. Now, there are a few things you might want to know about group. A group can have many users, and a user, they can belong to many groups, but groups can't be nested, meaning group can only have users. A group cannot have a group inside a group. That's not possible. And there's nothing called a default group that sort of automatically includes all users in the AWS account. If you want to have a group, then we will have to create a group. Now let's take this diagram for example. Now this is a diagram of a small company. Now the company owner creates an admin group for users to create and manage other users as the company expands every day. And the admin group creates a developer group and a test group. Each of these groups consists of users who are people, users who are applications that interact with AWS environment. So the different types of users we have are Jim is a user, Brad is a user, and Dev App 1 is a user, and so on. So each users have an individual set of security credential. Like I said, it's 1-to-1. And the 10 users that we see on screen are shared between, or they belong to multiple groups in the account. And managing group is quite easy. We set permission to the group, and that permission gets applied to all the users automatically in the group. And after we applied the policy, if I add another user to the group, the new user will automatically inherit all the policies, all the permissions that's already mentioned in that group. So administrative burden is sort of taken away. Administrative burden about user privilege or user permission management is sort of taken out with IAM. Alright, the next thing we will want to discuss is policy. A policy sets permission and controls the access to AWS resource. And the policies, these permissions and controls, are stored in JSON format. A policy is a very clear document. It defines who has access to a resource and what are all the actions they can perform. So in other words, policy is an entity in AWS that when a policy gets attached to an identity or a resource, it really defines the permission, what they can and cannot do. And AWS, it evaluates these policies when a principal, such as a user, makes an request. And the permission statement in the policy, it really defines whether the user is allowed to access a service or is he denied to access a service. Alright, let's take this example. Now we have a task. The task is to give Paul, who is a developer, access to Amazon S3 environment. And what you're looking at is a snippet of what a policy would look like. So these are some questions we will have to answer, or these are some questions the policy tries to answer. And once it found an answer, then it becomes a complete policy. So who wants access to the service? It's Paul who wants access to the service. And what action do Paul want? Now Paul wants to download, or Paul wants to upload objects in S3. In JSON language, it's otherwise called Paul wants to get information, Paul wants to put information. Otherwise, Paul wants to get object, Paul wants to put object in S3. And which resource does he want? Now, in this case, every bucket. The star symbol represents all buckets in S3. So, which resource? It's all bucket in S3. So, we can start reading already from the data present here. So, who wants access? Paul wants access. What action does he want? He wants to get, he wants to put. And what's the resource that he's trying to access, or you want to give him access? It's all the bucket in AWS. And when does he want? These are additional statement that goes in a policy. So since when does he want that access? He wants access till March 2nd, 2019. So all this who, all this action, all this resource, till the time all this gets allowed. So this is the statement that really defines. Now, does this all refer to an allow statement, or does this all refer to a deny statement? If we had deny here, it's the direct opposite of what we discussed. But we have allow. That means Paul is allowed to get and put access in an S3 bucket, and all the buckets in S3 till March 2nd, 2019, he's allowed to access the resources. So if we put all the information that we have gathered, or all the answers that we have so far, if we put together in a JSON format, this is how it's going to look like. So the effect is allow or deny. Here it's allowing, and the principal is any. Now who can access it? It's any. And action, it's any bucket in S3. Any action in S3, put get request, and the resource is any bucket in S3. So that's how a basic policy would look like, or that's how a basic policy is formed, by answering those basic questions. So let's talk about the types of policies. So we have two broad categories: managed policy and inline policy. Now, managed policy, it's the default policy that we attach to multiple entries, be it users, be it groups, and be it roles in our AWS account. On the other hand, inline policy are the policies that we create and manage them. And these policies are embedded directly into a single user, group, or a role. So if I need to brief it a little bit more, then managed policies are standalone identity-based policies that we can attach to multiple users, groups, and roles in our AWS account. We can use two types of managed policies. In other words, managed policies, they themselves have two categories. One is AWS managed policies, which is created and managed by AWS. And the other one is customer managed policies. Just like the name says, it's managed by the customer. Now we can create and edit an IAM policy in Visual Editor, or simply create a JSON policy document directly and upload it in the console and start using them. So that's managed policy. On the other hand, inline policies are policies that we create and manage, and that are embedded directly into a single user, group, or role. Let's talk about this next component called role. Now this role is very similar to everything that we discussed so far. It's a set of permission that defines what actions are allowed and denied by an entity in an AWS console. The role is very similar to an user. I said very similar. I didn't say it's the same as the user, but I said it's very similar to the user. And the difference is that user is hard-coded. User permissions are hard-coded, but the role permissions are accessed by any entity, be it a user or be it an AWS service, and moreover, the role permissions are temporary. On the other hand, user permissions are permanent and the role permissions are temporary. So in detail, a role is very similar to a user in that it's an AWS entity with permission policies that determines what the identity can and cannot do in AWS. Now, instead of it being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Roles generally do not have a long-term credential, password or access keys associated with it. It does not have long-term credentials. It only has temporary credentials created dynamically and provided to the user as and when the user assumes a role and wants to access any service. Roles can be assumed by users, roles can be assumed by applications, roles can be assumed by services that normally don't have access to AWS resources. For example, you might want to grant a user in your AWS account access to your resource that they do not normally have, or grant users in one AWS account access to resource in another AWS account. Now this is something that we don't have by default, and this is something we may not need all the time. Or you might want to allow a mobile app to use AWS resource, but you do not want to save the key or save the credential or save the passwords in the mobile app. Or sometimes you might want to give access to resources who already have identities defined outside of AWS, like a user who's already an Google or Facebook authenticator. If you want to give them some service, or if you want to let them to access some of the resources in your account, we can use roles for that purpose. Or you also might want to grant access to your account to a third party, a consultant or an auditor, so they can for some time get some temporary access to audit our AWS resources. Remember, they're not permanent users, just temporary users. They want some temporary access to our environment till the audit is over. So for those cases, roles are a very good use case. So let's take this example. Let's see where role sits, and let's see how roles give permission to other services. So here is a scenario where an EC2 instance wants access to an S3 bucket. By default, though both of them were created by the same username or the same admin, they do not have access by default. So by default, they don't have access. And I also do not want to give permanent access, one-on-one hard-coded permanent access. Instead, I would like to create and share access. So that's possible through roles. So coming back to the discussion, the scenario here is that an EC2 instance wants to access data in an S3 bucket. So the first thing is to create a role or a permission. We saw how that's done, right? Using policies. Roles use policies. Policy is the actual working engine for any permission related actions, right? So create a role with an appropriate policy that gives access to S3's bucket, and then launch an EC2 instance with the role attached to it. We said roles are assumed by any entity, right? It could be user, it could be an application, it could be a service, it could be another resource in AWS account. So here it's another resource in AWS account, right? So we create a role and we attach it to an EC2 instance. So now the EC2 instance can assume the role. Now the same role can be attached to another EC2 instance. The same role can be attached to another user. The same role can be attached to another database service. We get the idea, right? Roles can be assumed by anyone. So when the EC2 instance wants to communicate with S3, it contacts the role, and then the role gives this EC2 instance some temporary username and password that expires after 1 hour, let's say. So it's a temporary username and password. Now with that temporary username and password, the EC2 instance can access the S3 bucket and access the file with the credential that it already has. And that credential is a temporary one. And the credential will expire after 1 hour, or how much ever time the admin sets it to be. And then the next time when an EC2 instance wants to contact S3, it will have to contact the role, and the role will propose a new access key and secret access key. In other words, a new credential. With that new credential, the second time the EC2 instance will be able to contact the S3 bucket and get the information. So the password is not a permanent or a one-time or a hard-coded password. It keeps rotating. It's a token. It's a secure token that an Ec2 instance or any application that uses the role gets to access the resources on the other end. Well, let's talk about the features of IAM. The main feature of IAM is that I can create separate username and password for individual users or resources, and I can delegate access. Now, those days where we had just one username and password for admin and we need to call the other person to get the username and password over the phone, if it gets compromised, the whole account gets compromised, stuff like that, those issues are gone. I can create separate username and password for all 1,000 users in my account. No more username and password sharing. I can manage access to all those 1,000 accounts in a very simple and an easy way. So IAM provides shared access for all the 1,000 users in my account. It provides shared access to the AWS environment. And the permissions that can be given through IAM are very granular. Now we saw how restrictions can be put on GET requests. We can allow a user to download information and not update an information. So that's possible through the IAM policies that we looked at some time back. And with the use of roles, we're authenticating an Ec2 instance instead of the application running on top of it. So if there are like 10 or 20 applications running on top of an Ec2 instance, instead of creating a separate username and password for all those 20 instances, I can create a role and assign that role to the Ec2 instance, and all the applications running on the Ec2 instance get a secure access to the other resources, use the role credential that's provided to that Ec2 instance. Now, besides username and password, IAM also supports multi-factor authentication, where we provide our credential, the username and password, plus an OTP from our phone or an randomly generated number that gets displayed in our phone before Amazon console or before Amazon CLI would authenticate and lets us access some of the service in the account. So it's called multi-factor authentication. It's username and password plus something else from what you have. IAM also provides identity federation. If a user is already authenticated with a corporate AD or Facebook or Google, IAM can be made to trust that authentication method and then allow access based on that authentication. Now, without federation, what would happen is the users will have to remember two passwords, one for on-premises and one for cloud. Anytime they work on on-premises, they'll have to use one set of password, and anytime they switch to the cloud, which is going to be very frequent in every day. So anytime they switch to the cloud, they will have to again type in the cloud username and password. Now, with identity federation, we can sort of federate, or we can connect both the authentication systems, both on-premises and IAM. So users can just use one username and password for both on-premises and cloud environments. And all that we saw so far, it's free to use. There is no additional charge for IAM security. There is no additional charge for creating additional users, groups, or policies. It's a free service, comes along with any account. IAM is an PCI DSS compliant product. IAM comes with password policy where we can reset the password remotely or rotate the passwords remotely. And we can set rules like how a user should pick and password. It should not be the one that was used in the past, any of the past 3 times, stuff like that. So you get the idea, right? How the features of IAM help us to build an secure authentication and authorization system in or for our AWS account. All right, it's time to do a quick lab. Let's put all the knowledge that we have earned so far together and apply it and try a lab and solve the problem. So here's a problem statement. We need to create an S3 bucket for a company where users can read or write the data only if they are multi-factor authenticated. So there could be like 20 users in an account, but a user is allowed to read or write a data in an S3 bucket only if the user is multi-factor authenticated. This is a very good use case if we have sensitive data in an S3 bucket and you only want privileged or MFA authenticated users to do changes to those buckets. And for those privileged users, you would enable multi-factor authentication. So let's see how that's done. Before that, let me talk to you a bit more about multi-factor authentication. Now, multi-factor authentication is that additional level of security process. It's provided by AWS. Here, the user's identity is confirmed only after the user proposes or the user passes two level of verification. Now, one being the username and password, and another being an OTP that gets generated. In this case, it's the mobile phone. It could also be an RSA token key that generates the one-time password. That's possible as well. But in this case, it's the mobile phone. Now, that's going to be very similar to how we log in to our Gmail account sometimes. When we log into a Gmail account and if you have the proper setting enabled, it's going to send an one-time password to the mobile phone, and only after we put that information, it's going to let us log in. Let's see how all this is done in an AWS account. So the first thing is to log in to the AWS account, create a user, and attach the user to the virtual MFA device. Now we're going to use Google Authenticator here, and we're going to attach the user to Google Authenticator and make the user use the Google Authenticator one-time password every time he logs in to the account. Now this is in addition to the username and password that he or she already has, right? So the first thing is to log into the account, connect or sync the virtual appliance with the AWS username and password. Now when we sync, there will be an one-time password that gets shown in the phone. Type in the password in the AWS console, and then the phone and the username comes to sync. And from that point onwards, the user, anytime they log in, they will have to propose their username and password, which is the first step of security. And then once they typed in the username and password, type in the MFA code that gets generated on the phone. That would be the second step of security, or the last step of security. Once that is done, the account is going to let them log in and access the AWS resources. Alright, so in order to test IAM, MFA, S3 together, this is what we're going to do. So we're going to create a bucket, and we're going to have two users, and we're going to allow or deny access to the S3 bucket to those two users based on whether they are MFA authenticated or not. And on purpose, we're going to assign MFA to one user and no MFA to the other user. Like you might have guessed by now, the user with MFA will have access to the bucket, and the user with no MFA attached will not have access to the bucket. Both of them are going to have full S3 services, but MFA, like I said, is one layer above the other permissions. MFA stands at all time. So irrespective of whether the underlying policy says but they have full access to the S3 bucket, they're not going to, because MFA stands on top of it. Let's see how that's done. To begin with, firstly, we need a bucket. So let's create a bucket. So I'm in my AWS console. So let me go to S3. And in here, create a bucket. Call that bucket as Simplilearn MFA bucket. And let me put it in North Virginia and create. Alright, so that's done. Now I'm going to put a separate folder in here. I'm going to create another folder in here, and the name of the folder is tax documents. Now this is where I'm planning to keep my tax files, and I only want my privileged users to be able to upload and download information from the tax document. So on the bucket side, it's partially done, or on the S3 side, it's partially done. So let's go back to IAM, and here we're going to create two users, one a junior employee and another one an senior employee. The senior employee is the one who's going to have MFA access and more access to the S3 bucket, and the junior employee is the one who's not going to have access to that particular bucket. So let's get started. Let's create an user under IAM. Click on users, and let's create a user. Call this user junior right. So he's a junior user, and for the password, set a password. The user does not need to create a new password at sign in, because it's a test environment, and the user who creates the username and the user are the same person. So let's keep it simple. Username, password management console access. And this user is going to have full S3 bucket access. All right, this is really the policy. We should be familiar with this JSON document by now. It says effect is allowed, and what action? Any action in S3, and what resource? Anybody who's attached to it. Review and create a user. So this user is having S3 full access. Now let's create another user, call them as senior employee. All right, attach a policy to the user. From the surface level, both of them have the same permissions. Both of them have S3 full access. All right, so both of them have S3 full access, as we see. There's one thing different we're going to do to this senior employee. Now we're going to attach MFA to this employee. So the way we would do it is under the summary section of that particular user, click on security credential, and see, here is a place we can attach an MFA to this user. So let's attach MFA to this user. For MFA, I can use both virtual MFA or hardware MFA. This being a lab environment, we're going to use virtual MFA. Now, that is an application. There are a lot of applications available, but there is one application that I'm using at the moment called Google Authenticator. So once we have installed the application, once it is running, so I can go to virtual MFA device, and once it is running, I can scan the code using the Google Authenticator in my mobile phone. Once you turn on the application, and once you do scan the barcode that is showing right here, now that's going to give us codes that we can use. And we will have to put in those codes here twice. We'll have to wait for some time, and it would generate a second set of key that we can put. So my first set of key is 402351. Right, I'll have to wait for some time, and then it would throw me a second set of key. It's like validating twice right here. So let me put in my second set of key. So this user is now MFA authenticated user. So anytime this user logs in, it's going to ask for MFA. Anytime this user proposes something, it's going to attach the MFA key along with it. Alright, so we're done with the IAM. What have we done with IAM? We have created two users. Both of them have S3 full access, but one of them have MFA access and the other one does not have MFA access. And based on whether the user is having MFA or not, we're identifying privileged users by this MFA. Alright, so based on whether the user has MFA or not, we're going to allow deny access in the S3 bucket. So we already have a bucket, we already have a folder, and this is a very privileged folder path. Here I would like to restrict access based on whether the user is having MFA or not. So let me create a bucket policy here. Now here's a policy that I have written. The policy says that, under tax document folder, give access only if the user is MFA authenticated, right? If the user is not MFA authenticated, simply deny the access to that user. So as you might guess right now, the user 1 will not have access, or the junior employee will not have access because it's a privileged, and junior employee might tend to delete them unknowingly, and only privileged users get access to the tax document because it's confidential, because it's privileged, because if it gets deleted, we won't be able to get it back for those reasons, right? So apply the bucket policy. Now try logging in as the different users and see how the permissions are applied on both the users. All right, so let's make a note of the IAM URL. and then the two usernames and password. Let's log in. So let me log in as the privileged user. Sure enough, I'm being asked for an MFA code. Let me put my MFA code. So let's directly navigate to the S3 bucket. Right, here's my privileged path. Let me try uploading some content. Claim forms. Sure enough, I'm able to upload content into it. Will I be able to delete? Yes, I'm able to delete as well. Now let's see what's the situation for the other user. So let's log in as the other user. Navigate to the S3 bucket. If you noticed, when logging in, it did not ask for an MFA code because the user is not set up for MFA. So navigate to the folder which we want to test. Now try adding some files. As you see, it's failing to add content to this bucket. It shows error because the bucket policy is requiring MFA and this user is not MFA, and we did that in IAM or under IAM. But still, as you see, they will be able to view the content in the bucket. They can do all that. We have specifically restricted access to upload and download content from the bucket, and that's exactly this user is now denied with. Welcome to this new video lesson where we're going to learn about CloudFormation. In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work, and CloudFormation, it sort of eases that environment. Now, CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now, that can be avoided using CloudFormation. Now, without CloudFormation, it still is a problem because the resource or the bandwidth that is needed for the application development is not provided, because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now that leads to a discussion about what is CloudFormation. So let's talk about, or let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an Ec2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in Cloudfront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the Ec2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are reusable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about AWS, how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of Ec2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. right? So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second and stack. All right, let's understand the two major components in CloudFormation. By now you might have guessed it. The two major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key, and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, and this transform section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an Ec2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template, now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. the latest version, format version as of now is the one that was updated on 2010. Now the value of the template format version, it has to be an string. And if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description. And this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMapInStrict function. Let's take this example. Let's say based on a region, if we want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template, during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions could be helpful. For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use NOT functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 Instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if we want to map an elastic block store volume, or if we want to map an name of the bucket,
in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type in the template, it identifies that the type of the resource is an S3 bucket. And the properties are the additional optional information that we can specify to our resource. For example, if it is an Ec2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and sort of import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template. And it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. All right, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have, if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. The attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. This is a very good use case when we do auto scaling. And this creation policy can be used only with a limited number of services like auto scaling and Ec2 instances. Some of the use cases would be if you want to install a software application on an Ec2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. Here in the syntax that we're looking at, the auto scaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted. And by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it, or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first, and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket. The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an auto scaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an auto scaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the auto scaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template, right? So stack is a collection of AWS resource that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template that is in a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource, and it can be managed as a single unit. And the CloudFormation's template defines a stack in which the resource can be created, deleted, or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, there's a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs, and provide us with the ability to install software and use a remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from an Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating, or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update, and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update, and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating and LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have, look at that, that's going to have MySQL installed in it, that's going to have PHP, that's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we are provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn. Simplilearn LAMP stack, and what could be the DB password? And DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. Alright, so there's an issue with the password. Password should only have alpha numeric characters. Get that. So let's go back and create a new password. Right. It also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here in the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. All right, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. All right, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. All right, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. All right, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. All right, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. All right, so I'm going to create a stack, and from here I'm going to pick a sample stack. If we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. All right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. All right, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here. Right, so I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto scaling group, and putting some restrictions that nobody will be able to access the Ec2 instance directly, but they should be able to access the Ec2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. All right, in this lab, we're going to create Elastic Load Balanced Auto Scaling group, which is going to create a load balancer and an auto scaling group. And that auto scaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters, we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously created a target group, now it's creating the application load balancer itself. All right, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. All right, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go.
Thank you, Samuel, for that wonderful session. I hope you guys found this informative. We now have Rahul, who will take you through the various certifications available for you in AWS. And then he will also guide you how you can become an AWS certified solutions architect. Over to you, Rahul.
In today's job environment, being certified marks the difference between getting your dream job and losing it. If you're a fresher or just someone who's starting up, it's highly likely that you're confused in choosing the right certification. I'm going to help you figure it out. I'm Rahul from Simplilearn, and today we're going to talk about AWS certifications. So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for the next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now, the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. Now, the AWS certified cloud practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now, the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps Administrator, Solution Architect, Developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices, and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get the certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate certification or the AWS Certified SysOps Administrator certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now say I wanted to schedule an examination. So for example, I want to do the Solutions Architect certification. So first I would go there. Now here I can click on register now and the process continues, or I can click on learn more. By doing this, again I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements, and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. At domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost optimized architectures, and 5 to define operationally excellent architectures. Now like you've seen here, you've selected one certification and learned it in detail. You can do the same for any of these other certifications. And today I'm going to tell you how you can become an AWS Solutions Architect. So who is an AWS Solutions Architect? Now, the main role of an AWS Solutions Architect is to help you deploy your applications on the AWS platform. Now, this is nothing but a cloud computing platform. So, it's not to say that you can't deploy your applications on the cloud computing platform yourself. It's just that when it comes to organizations, the applications that you need to deploy become a whole lot more complex. That's where an AWS Solutions Architect can help. Ever since cloud computing became a thing, companies around the world have started migrating their physical infrastructure onto the cloud. That's what an AWS Solutions Architect does. They help you migrate your physical infrastructure onto the AWS cloud. Companies around the world work on a budget, and an AWS Solutions Architect will help design a cloud infrastructure based on the organization's budget. Before that can be done, however, an AWS Solutions Architect has to create a design with an intricate and detailed blueprint of the cloud infrastructure that they plan to set up. Now, AWS Solutions Architects also have to focus mainly on non-functional requirements like usability, reliability, scalability, and performance of the cloud infrastructure. They're also responsible when it comes to minimizing risks that an organization can face when it comes to cloud computing platforms. Now, they could face risks like security leaks, calculation mistakes, and application downtimes. An AWS Solutions Architect has to ensure that these don't happen. Before we can talk about how you can become an AWS Solutions Architect, I have some exciting news for you guys. We've launched our own YouTube community. You'll get to see a lot of quizzes, polls, offers, and much more to make your learning experience a whole lot more fun. You can find all of this on your subscription feed, or you can also click on the top right corner right now to get started. And let's get back to how can you become an AWS Solutions Architect. Now, to become an AWS Certified Solutions Architect, you need to clear the AWS Certified Solutions Architect Associate Level Examination. Now, here's some details about it. The exam score ranges from 100 to 1000 marks, and the minimum passing score is 720. However, there's a catch. The passing marks are actually set using statistical analysis, so they can be changed based on how difficult the examination actually is. The exam fee is $150. And you can also take a practice examination, which costs $20. Now, regardless of the examination you take, be it Solutions Architect, SysOps Administrator, or Developer, any associate level examination costs $150. For the professional level examination, it's $300. Now, if you want to learn more about the AWS certifications, I suggest you click on the top right corner and watch our video AWS certifications in 10 minutes to learn more. Now, the exam duration is of 130 minutes, and you have 2 types of questions, multiple choice and multiple answer. Now, the multiple choice questions have 4 options, out of which 1 of them is right, and you have multiple answer, where you have 5 options, out of which 2 of them are correct. You can take the examination in English, Japanese, Korean, and simplified Chinese. Now, let's talk about how you can schedule an examination. First, let's go to Google and search for AWS certifications. Click on the first link. So on this page, we can go to the bottom and find the different certifications AWS provides. Click on Architect. and select the AWS Certified Solutions Architect Associate certification. Click on Register Now. And here you need to click on the AWS certification account. You can sign in with your Amazon account or create a new one. I already have an Amazon account that I'll be using for signing in here. In case you don't, you can click on the Create Your Amazon Account button here and create an account for yourself. Now after that is done, you can schedule a new examination. And you can scroll down to the bottom. Here, AWS Certified Solutions Architect Associate Level Certification. Click on Schedule Exam. Press Continue. And here you need to select your language, which I'm assuming is English. I'm from India, so I don't need to change anything here, but you can change your country or time zone and other details based on your requirement. And select your preferred month. I want to do it in October. Now select Search for Exam Center. Select the one that's closest to you. I'm going to select this one. And here you can select the day that you want to take your test and the time available. I want to do it on the 15th. I select the time that I want and press Continue. Now you can go through all the details here, change them if you want to, otherwise you can press Continue. After this is done, close. And here we have the final step, which is the fees. You can enter your details here and pay now to finish the process. Now let's look at an outline of the exam content. Now what you're going to see in the exam are 5 major domains, and here you have each of the domains with their respective weightages. First, you have at 34% designing resilient architectures. At 24%, you have both defining performant architectures and specifying secure applications and architectures. At 10%, you have designing cost-optimized architectures, and at 6%, you have defining operationally excellent architectures. Now let's look at each of these domains in detail. Now the first domain, or design resilient architectures, can be divided into 4 parts. Firstly, you need to know how you can choose reliable or resilient storage using services like AWS S3, AWS Glacier, and AWS EBS. Then you have how you can design decoupling mechanisms using AWS services. Now this is possible with the help of AWS SNS. Now these aren't the only services that enable this, these are just some of the services. Then how you can design a multi-tier architecture solution. Now this is important because you need to know how you can create a solution that involves several other services. Then you need to know how you can design highly available and fault-tolerant architectures. Now for the second domain, defining performant architectures. First, you have how to choose performance storages and databases. Services that are used are AWS RDS, AWS Redshift, and AWS DynamoDB. The second step is how you can apply caching to improve performance. A service that can be used for this is AWS ElastiCache. Third, how you can design solutions with elasticity and scalability. You have AWS Lambda, AWS CloudWatch, and AWS Data Pipeline. Now, for the third domain, which is specifying secure applications and architectures, you need to know how you can secure applications using services like AWS Inspector, AWS CloudTrail, and AWS IAM. You need to know how to secure data using Cloud HSM and AWS Macie, and how you can define the networking infrastructure using Cloudfront, VPC, and Elastic Load Balancer. For the fourth domain, you have designing cost-optimized architectures. Firstly, you need to know how you can design cost-optimized compute solutions. You can use AWS EC2, Elastic Beanstalk, Lambda, and AWS Lightsail. Then, you need to know how you can design cost-optimized storage solutions using AWS S3, Glacier, EBS, and Elastic File System. And the final domain, to define operationally excellent architectures. You need to set up design features and solutions that enable operational excellence. Now, some of the features are that you perform operations as code, you annotate documentation, you make frequent and small reversible changes, and anticipate and tackle failures. Now, let's have a look at the job opportunities when it comes to AWS Solutions Architects. Now, if you have a look at this graph, you can see that AWS has always provided a lot more job postings as compared to the other two giants in the cloud computing domain, which are Microsoft Azure and Google Cloud Platform. Now, if you do a little bit of research, you'll find out that there's a significant lacking of experienced personnel when it comes to AWS. So I would suggest this is the best time for you to get certified in AWS. So how can Simplilearn help you with your AWS certifications? Now we're on the Simplilearn homepage. And here we have the AWS Solutions Architect course. On this course, which is the AWS Solutions Architect Certification Training course, we have 36 hours of instructor-led training, 20 hours of self-paced learning, 16 live demos, 3 simulation exams, 3 hands-on practice projects, and so much more. Here, our main emphasis is on making sure that you have enough hands-on experience with the services that you crack the examination at your first attempt. So here we also go through some of the more important services that you need to learn, like IAM, VPC, EC2, S3, and so much more. We'll also talk about databases, application services, security practices, disaster recovery, and so on. We even have practice examinations to help you prepare for the real one.
Thank you very much, Rahul. That was great. We have now reached the final segment of this complete AWS tutorial. We will now have Samuel take you through 80 of the most important AWS questions that might just appear in your AWS or cloud interview.
I'm here to walk you through some of the AWS interview questions which we find are important, and our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute, EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Auto Scaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event-initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS, file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used. Right, so that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have Cloudfront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that gets asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship. Right, so a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there. You should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is auto scaling? What do we achieve by auto scaling? So in short, auto scaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So auto scaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because auto scaling is going to handle it for us. So business does not need to worry about it. And auto scaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is auto scaling. The other question you could get asked is, what's geo-targeting in Cloudfront? Now we know that Cloudfront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for Cloudfront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit, not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? Cloudfront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it get cached there forever. and the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent on, that's depended by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an Ec2 instance to a better Ec2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger Ec2 instance type or with a bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so. And it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount. Stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it, and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an Ec2 instance. An Ec2 instance does not always have to be logged in through the console. You could use PuTTY to log into an Ec2 instance, and like the jump box, like the proxy machine, and like the gateway machine. And from there, you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3, and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system would scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account. It could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, have their own logging, like S3. S3 has its own login, and Cloudfront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment. And we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config. All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. Alright, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. Cloudfront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create a secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as and when the traffic increases, as and when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime you don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And If your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to how do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes. Not only the state changes, the auto scaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage. Very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific, so we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service, and it's one application. Users access from everywhere or from every part of the world, so we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with Cloudfront. Then Cloudfront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And Cloudfront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service, right? It's not bound to any region. So when you activate Cloudfront, you're activating it away from region or availability zone. So when you're activating a Web Application Firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. Cloudfront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question: what are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon, NAT instance is managed by us, and availability of NAT gateway is very high and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. Billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But a NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product. But NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you're always lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance. And anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelist put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually a hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here, in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide Power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now, these are different hardwares, different CPU itself that the cloud providers do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch. And once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes. Right, it's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you. All right, this is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the sysops side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. It can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI. So a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI, just like the name says. It has, as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security, monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all our systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. Alright, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup, but here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are, S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an Ec2 instance. Right, just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize. Right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to or who should be or should not be given access to a certain server. And you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. But if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication, is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1, and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Alright, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are cloud watch that make sure that the data is moved, no data is failing. Again, there's cloud watch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default it's not allowed, but if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices, and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, all right, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. Right? That's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers, or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who, and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, and stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC. except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be a malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test based on the score. They can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation if you come across. Alright, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's a thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design and you need millisecond latency and it has to be a database. Alright, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. Alright, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS, RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single-digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. All right. Let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? Alright, let's list the services. So it talks about real-time monitoring. Firewall Manager, what does it provide? Now, Firewall Manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS Guard Duty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but I mean, we have one more option left, that's EBS. So what's EBS? EBS is a block storage, elastic block store. If we abbreviate EBS, it's elastic block store. So all three of them are easily out of the question. The first one is to manage, second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and Guard Duty, that's monitoring. So easily we can actually find ourselves slipped towards picking Guard Duty, but know that Guard Duty is only for gaining security insight, but not about gaining AWS service insight. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide. It has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. Alright, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. Alright, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right, which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? Alright, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into a mobile platform. Alright, so we have like four options here. Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up and mobile platform. Alright, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app. Pretty much we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who is on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's identity and access management. So it's identity and access management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey that it's actually a security service that uses machine learning. Kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like. But we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, and you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in a company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have service or not. So that helps us to get a track of who is able to use, who's not able to use certain service and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API Gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API Gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? It's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC, that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API Gateway, we know that it's a managed service that makes it easy for developers to create, publish, maintain, and monitor APIs. and secure API. So that has completely to do with API, not with IP. Cloudfront, we know about Cloudfront that it's a content delivery network and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally so users can easily access them and download them easily. All right, so that's Cloudfront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow deny connection based on the security group, access control list, and the routing table it has. So that's the right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks. So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database. Kind of matches the requirement. We can resize it as and when needed. All right, looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database. So that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed. It can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. Alright, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? Alright, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the four services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. All right, let's talk about Mechanical Turk. It's a web service that provides a human workforce. That's the definition for it. For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other two are already out of the equation. Now DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. Alright, this sounds interesting. Let's look at this one. This service is used to
make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. Alright, the first one, Amazon Elastic Container Service. Kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing. I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. Right, so at this point that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 Auto Scaling. EC2 Auto Scaling. EC2 is Elastic Compute Cloud, which is a server, and Auto Scaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other two services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The requirement in the question was run code without provisioning a server, and without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right? The right one would be AWS Lambda.
Second part in AWS interview questions. If you haven't watched the first part yet, please go back and watch the first part. We have a lot of interesting questions there which will better prepare you for the interview. Alright, let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new auto-scaling group? Now this is when you are taking an instance away from the auto-scaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the auto-scaling, you might need to re-add that instance to the auto-scaling group. Only then it's going to take part in it, right? Only then the auto-scaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the auto-scaling group. Irrespective of what they tried, the instance was not getting added to the auto-scaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the auto-scaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance
to the auto scaling group. There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to auto scaling group, right? If you have multiple auto scaling groups in your account or in the region that you're working in, then you're going to be posted with the different auto scaling groups that you have in your account. Let's say you have 5 auto scaling groups for 5 different applications. You're going to be posted with 5 different auto scaling groups, and then you would select the appropriate auto scaling group and attach the instance to that particular auto scaling group. While adding to the auto scaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the auto scaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the auto scaling group. So it's actually a 7-step process, adding an instance back to the auto scaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, buying an infrastructure, buying the bandwidth, buying the switchport, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves self-aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some cloud formation questions. This is a classic question. How is AWS Cloud Formation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button, right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the cloud formation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the life cycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question: what happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the fifth point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot on the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instance Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, Instance Store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and Instance Store is locally attached to the instance, or locally attached to the host of the machine. We cannot detach an Instance Store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data, and another one is EBS is permanent, Instance Store is volatile data, and Instance Store, with Instance Store we won't be able to detach the storage and attach it to another instance. And another feature of Instance Store is data in an Instance Store is lost if the disk fails or the instance is stopped or terminated. So Instance Store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not Instance Store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System, right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted, or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list. And from there, we can use the region selector in the console navigation bar to select the actual region in which we want to work on. And from there, ensure that we have selected the right template. Some of the templates would be, EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally, review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, Simplilearn.com / some web page, Simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, web application firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or web application firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked to your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times, depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource, and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM, and how does IAM help your business? Now, 2 important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users or non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory. They could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that will only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to provide customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have two different or three different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if we have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. You wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be, how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service. right? It's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be, how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTP, HTTPS access, or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given? Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail, or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime, and you want to identify, let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of these services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime the new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3-year reservation, and in return we get a very low per hour pricing because we're paying upfront, it's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about auto scaling, how will you understand the different types of auto scaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. All right, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right, that's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres, SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres, SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? All right, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency, or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS Ec2 Auto Scaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Auto Scaling is in introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientists with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's service. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications. And they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Auto Scaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is auto scaling. Right, that's a basic service and solution architect course, is it? Auto scaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and PostgreSQL. Which service are we referring to? Amazon Aurora, Amazon Elasticache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elasticache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and PostgreSQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification service.
Microsoft Azure Full Course. In this full course, we will learn everything about Azure in detail. We'll begin this full course video with what Microsoft Azure is, then we will look into Azure and its concepts in detail, then our experts will give you a quick training on Azure services, then we will see what is Azure Machine Learning and Azure Active Directory. Next we will see Azure Virtual Machine and Azure Virtual Network. After that, we will be looking into a few major differences between AWS and GCP, and after that we will have a quick understanding of how the famous cloud providers AWS, Azure, and GCP are different from each other. Finally, we will conclude this video by discussing 25 important Azure interview questions and answers for beginners and experienced level candidates. By the end of this video, I can assure you that all your Azure related queries would have been answered. For this training with me, I have our experienced Azure experts Sam, Rahul, and Alankar. Together, we will take you through the various topics of Azure. So let's start with an exciting video on the Microsoft Azure Cloud Provider. Before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn.
Hi guys, this is Rahul from Simplilearn, and today we'll be talking about one of the fastest growing and second largest cloud computing platform in the market right now. I'm talking about Microsoft Azure. Now, before we begin, let's talk about what we'll be covering in this video. First, we'll talk about why you should be interested in cloud computing, what exactly is cloud computing, what is Microsoft Azure, some of its services, and the uses of Azure. Now, let's start with why you should be interested in cloud computing. Now, let's say you have an idea for a revolutionary application, an idea that ticks both the boxes when it comes to good applications. One, it has great user experience, and two, it'll be highly profitable. Now, for it to be successful, you'll have to release it on the internet. People need to use it, they need to spread the word, and then it'll become truly famous. However, for that, you're going to need servers, storage, developers, a dedicated network, and application security to ensure your application works the way it does. Now, these are a lot of components, and that's where the problem lies. There are two major disadvantages to this approach. The initial setup is very expensive and risky, which means this requires a huge amount of capital upfront to ensure that it works properly. And the downside is, if your application does not become famous or it doesn't return as much as you expect it to, you're probably not going to get the money back, which means it provides a huge amount of risk. And then on the flip side, if it does become famous, your number of users have increased, which means that you'll have to buy more servers and storage systems to keep up with your demand. And this problem can be solved with the help of cloud computing. Now that you know why you should be interested in cloud computing, let's go into the details of what exactly is cloud computing. Now, cloud computing is basically a platform that gives you access to a number of computing resources. And this is possible with the help of the internet. Now, as a user, all you need to do is go to a cloud service provider through your laptop or your computer, through the internet, of course, connect to that cloud service provider, and then there you go. You have access to computing resources. Now, computing resources may include, serverless computing, virtual machines, storage, and so much more. Now, let's dig a little deeper. Now, basically, these cloud service providers actually have massive data centers. Now, in these data centers, what you have are hundreds of servers. Also included are storage systems and mainly several organizations' critical components. So these are very secure, safe locations where a large amount of data is stored, hence the name data centers. Now, it is to these data centers that users actually connect to collect their data or use it. So actually, users can access any service based on their requirement. Now, like I told you, there's a number of services the user can use. For example, now if you want a notification every time someone sends you a message, or perhaps once you get an email, you need a copy of it created. Now, for all of this, there are services. And most importantly, almost every cloud service provider has this option where users only pay for the service that they use. So there's no charge upfront where they tell you that you need to pay X amount of money so that you can use our services. You're only paying for the amount of time that you're using these services. Now, cloud computing is used for a wide variety of reasons. Firstly, there's machine learning and data analysis. Now, basically, there are services that analyze your data and tell you how you can work with this data better. Then there's data storage and backup, streaming media content. For example, did you know that the shows that you watch on Netflix, actually all of them are in the cloud? So you're connected to the internet and you browse through Netflix and you get access to the videos. These are possible with the help of cloud service providers. There's creating and testing applications, automating software delivery, which is a component in DevOps, and hosting blogs and applications. So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now, it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched in February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of the most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
I'm Sam, an Azure Cloud Architect working for Simplilearn. And I'm more than glad to walk you through this session where we're going to talk about Azure in great length and breadth. And if you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. And without any further delay, let's get started. Everybody likes stories, right? So let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with
what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now, Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in our organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service.
be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hour, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. If we use them for an hour, we only pay for that particular hour, and then we're done. No more billing
on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right, instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it, and it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now, we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available on Azure includes artificial intelligence plus machine learning plus analytic services to get or to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development, and I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible, and a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure and a lot more.
And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay-per-minute billing basis. Alright, and at no point, because of the pay-per-minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent, regardless of whether you choose Windows or Linux. It's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now the alternative for the batch would be queues, but in queues we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators so they can avoid the complex infrastructure problems, and they can focus only on implementing
workloads or taking care of their development, taking care of their application instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and this scale set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The scale set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine scale set? Just like I said, this virtual machine scale set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release. without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now, functions are serverless computing. Now, many times if you've heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource-intensive environment, this AKS helps us to simplify that environment. All right, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity, because we are geo replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, this Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It's very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns
and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of, so I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure CosmoDB. Now, Azure CosmoDB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure CosmoDB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure CosmoDB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about CosmoDB. So this CosmoDB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure CosmoDB and the SQL database is that Azure CosmoDB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure CosmoDB is it allows users to use key value, graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis cache. Discussion about Azure database won't be complete without we talking about Redis cache. Now, Redis cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis cache is based on a popular open source caching product, which is Redis, sometimes called as Redis cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis cache, this fast storage is located in memory with Redis cache instead of being loaded from the actual disk in the database itself. Now, this Redis cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis cache. And by using Redis cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis cache engine provides. So to summarize, this Redis cache, when we use Redis cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now, what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity. And not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps
administrators and developers that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service, and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now this portal can be used to organize our environment or the appearance of the environment or the visual of the environment based on our work style. And using Azure portal, users can control who gets to manage or access the resources, all from the Azure portal. And this Azure portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now Azure Resource Manager enables us to manage the usage of the application resources. Now we use Resource Manager to deploy, monitor and manage solution resources as a group, as if it's one single entity. Now the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are by nature separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. So let's expand on this. The content delivery network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling. That's one advantage you get for content delivery network, that's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay-as-you-go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now, ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now, this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now, these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability, and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now, these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now, Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now, those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions, because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic, and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant, because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs, and the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. You know, it has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices, which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the data lake store. This data lake store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this data lake storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this data lake store. And this data lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this data lake storage. And this data lake store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be, to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing, but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls.
a single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application, so it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates, or which kind of connects, or which kind of decouples both the environment. Now we have a queue in between, both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now, this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally, so it's immediately available when needed. So that's some additional feature, I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema, and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less, a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data, it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets, such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now, this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he started, or he again started his discussion, but from a different angle now. So he started to explain what are the capabilities, or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by
Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using, or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you, or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial, and I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on Create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. All right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now, right? So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio, so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. All right, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. Right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. Alright, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry, take the dog for a walk. That's gonna get stored. I can create another entry, book tickets for scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services, which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app. I strongly believe you enjoyed me walking you through this session.
Today, I'd like to welcome all of you to this training video on Azure. So here we have two friends having a conversation with each other. One of them says that her company is moving all of its physical data and migrating it onto the cloud. She says that they're using a cloud service provider known as Azure. Now, here's the problem. She doesn't really understand how cloud service providers work or even how the cloud does. Her friend decides to help her out. So in this video, here's what we're going to talk about. First, we'll talk about what is cloud computing, what is Microsoft Azure, what are the services that Azure offers, and then we'll have a look at a use case where we'll be applying one of these services to get a particular job done. Now for the first question, what is cloud computing? So cloud computing actually provides a platform through which you can access resources. Now these resources include servers, storage, application security, and other ways you can transform your data or get some use out of it. Now at the same time, you can also store, manage, and process your data. Now anything related to cloud computing is made possible only with the help of the internet. Now along with these things, there are several other things that you can do with cloud computing. Now let's have a look at some of the ways cloud computing is making our lives better. Firstly, you have services for just about every requirement that you have. Then you get access to the newest and most innovative technologies in the market right now. Cloud computing provides cost-effective solutions with flexible pricing. Now most cloud service providers work in such a way that you only pay for the amount of time you use that particular resource. Then you have one of the most important selling points when it comes to cloud computing, which is that data and applications are accessible from any part of the world as long as you have access to the internet. And finally, you have increased protection for your data and applications. Now you should know that there are several cloud service providers in the market right now, be it Amazon Web Services, Adobe Creative Cloud, Google Cloud Platform, and so much more. Now among all these platforms, there's one that's growing really fast, and that is Microsoft Azure. Now let's ask the question, what is Microsoft Azure? Microsoft Azure is actually a cloud service platform that allows users to build, manage, scale, and deploy applications by giving them access to cloud services. Now, these cloud services range from creating virtual machines to creating functions that run themselves without having to worry about hardware. Now, all of this is made possible only through the internet. Now, here are some things that you need to know about Azure. Firstly, it was launched on the 1st of February 2010. It has data centers in more than 42 regions across the world. They also say that 12 more data centers are in the making, which helps them say they're the only cloud service provider that covers these many regions. Next, Azure is preferred by 80% of the Fortune 500 companies, which means that the best of the best in the market only choose to work with Azure. And finally, Azure is the second largest cloud service provider in the market right now. Let's talk about Azure services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have data lake storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now, depending on how often a particular data is used, it is classified into different tiers. Now, all the data that is within the blob storage is unstructured data. Now, it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have queue storage. Now, with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have file storage. Now with file storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and an NoSQL key value store. Now this is used for creating applications which have a flexible data schema. And also, considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that. And by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have logic apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now, this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now, SQL database is also used extensively in migrating workloads to the cloud and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now, this is a globally distributed multi-model database service. Now, what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now, this is usually used in situations where you have a diverse and highly unpredictable workload. Now, let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now, if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. And now, let's have a look at how we can use one of these services to satisfy a particular requirement. So the friend asks that she needs one last bit of help. She wants her friend's help to host a website on Azure, and here's how we can do it. So now we're going to put one of these services into action. So this is the Azure dashboard. So from here, we are going to create a virtual machine within which we are going to create a website. A very simple HTML website nonetheless. So let's get started. So first what we're going to do is create a resource group. So what a resource group is actually a repository of all the resources like virtual machines or storage that you're going to use in your project. So in this, we need a virtual machine. So let's get that created. So first we'll name it demo East US and we'll create it. Now this will take a few seconds and that's it. So now that that's done, we go on add. So we're going to be using a Windows operating system. So we'll just search for virtual machine. We select this and create. Okay, so here we're going to select the resource group, the one that we just created. a virtual machine name. Okay. This storage and name. Passwords, and then just breeze through the rest of it. We can reduce the size, we don't need it this big. And create. Now that the validation is done, the next step is to create. Now this will take a few minutes, so we'll wait. And as you can see here, the virtual machine has been created. We'll go to resource. So here all we need to do is connect and download the RDP file. Let's see if we run this file and see what happens. Now this error shows up in a whole lot of systems that I've used. So there's a very easy way to troubleshoot this problem. So here's what you need to do. Now, so these are the problems. As remote access to the server is not enabled, the remote computer is turned off, the remote computer is not available on the network. So what we're going to do is go to networking and add an inbound port rule. Now we're trying to access a computer remotely, right? So to remotely access the computer, we would need to add an inbound port rule. So that's what we're going to do right now. So we can keep the source as any, port range as any, and our destination port as 3389. If you've noticed there, we'd actually have used the 3389 as the inbound port. And then we change the name as 3389. And this rule is added. Now after this is done, all we need to do, you can see here that if you refresh the page, this would be here. A new rule has been added now. So we'll go to overview and try to connect again. Do the same thing again. And this time it worked. So here we'll input the name and our password. And that's it. Now we just press yes. And there you go. The system has started. Now your virtual machine is started. Now in a while, the server manager will pop up. So there's some things that we need to do so that we can host the website. So the first thing is to create an inbound port. So we'll turn off the virtual machine for now. Come back to that later. First we'll go to our resource group. Check the name of our resource. And then we'll look at all its resources here. So here we need to find the network security group and add an inbound security rule. Press add. We take any source port range, and then we add port 80, which is the one that we're going to use, and we'll put the name as port 80. We'll add the security rule. This will take a few seconds, and that's that. Now it's allowed. Now let's go back to our virtual machine. Here you go. And let's get it started. Log in again. And there you have it. It's on again. Now we'll go to Server Manager. So we need to add roles and features. So most of this we can just run through. We'll leave them at the default values. Same. And here we need to add a web server, which is the IIS. So we'll select this. We add the features. Next. So we can add the .NET 3.5 features as well. Next. And we'll install now. Now we'll wait for the installation to finish. And now the installation is done. So now what we're going to see is if the website can be reached. Now we'll go to the public address which is given here. So we've come back to our original system. Click, and you can see that the IIS page has been created. Now we need to work more to create the HTML page. Here's what we'll need to do to run our website. So right now what we're getting is this, the IIS page. Now let's make it our own HTML page, a very simple HTML page. From there on we can create the website. So we go back to the virtual machine and then we go to C drive. So the IIS is located in a location which is in C drive, initpub and www root. So if you click on this, actually what you'll get is the page I showed you earlier, which is this one. So now we'll go to the server manager, click on tools and find the IIS manager. So we click on this and sites. Now there's a default website. We can now add a new one. The site name, demo. We need a physical path. We'll put it inside the folder we just saw, which is right here, C drive, initpub, www root, within which we'll create a new folder for Simplilearn demo. We save it and port 80 and okay. Now this is assigned to another site, so we'll change that, but we'll wait for that. Okay. Now for this we'll just change it. We'll click on this. So since both of them have the same port, we'll change that. Go here, edit binding. We'll change this to something else. Okay, and close. So now both are different, and now we can start our website. It's already started now. Now we'll start the website. Right click this, so manage website and start. And that's it. Now we will go to the initpub, www root, and we have Simplilearn demo. So here we will create the HTML website or the document. So index.html. Okay. Open this. It's a very simple website now, so we keep it, save it. And so here what we're going to do is save as an HTML file, but for all files. We close this. Now to make sure this is recognized as a .html file, we'll go to view, options. Here we'll hide extensions for known file types. We'll just rename this. And there you have it. It's a .html file. Now let's go back to our original computer and run this page. And there you have it. Now this is just the initial version. More work has to be done on it, but your first step is already done.
And today we'll be talking about machine learning in Azure. Before we move on, let me tell you what Azure is. So Azure is Microsoft's public cloud computing platform. It provides you with various services like compute, analytics, networking, and storage. So you can pick from these services to develop and scale new applications or run existing applications in the public cloud. Okay, so once you log into your Azure portal and select machine learning as your service, you'll be redirected to this page. Now on the right hand side, you can see there's an option called My Workspace. So once you click on My Workspace, it will take you to a new window, which is Machine Learning Studio. But before that, let me give you a small idea of what My Workspace is. So any data that we get into our Machine Learning Studio, we analyze it and that is presented under My Workspace. Now on the left hand side, you can see there are a few options under Machine Learning Studio page. So let me go through those options one. So the first option is projects. So project basically gives you a list of all the experiments that we have worked on. Then comes experiments. So experiments are all the programs that you work on to create a model. After that, it's web services. So since Azure is a cloud computing platform, we know that all the data needs to be uploaded over the cloud. By data, I mean all the experiments that we have needs to be uploaded over the cloud. So web services gives you a list of all the experiments that we have and is over the cloud so that you can access it from anywhere. Then comes notebooks. So notebooks are basically space where you can explore analytics, you can create your own code, you can visualize it, and at the last you can share it with your peers. Then is datasets. So the dataset gives you a list of all the datasets that you have in your Azure portal. Now when you click on sample, these are all the sample datasets that Azure has provided as to the users. Now comes train models. So while working in an experiment, you'll come to a point where you need to train your model. So this gives you a list of all the models that you have trained in your Azure program. Then at the last you have settings. So any changes that you make is done under settings. So now that we are done with this, let's go to the next half of our Azure tutorial. So on the left hand side, you can see there's an option called new. When you click on new, it will open a window. So this window gives you a list of all the templates that we have in our Azure Machine Learning Studio. Okay, so since we are working from the scratch, we'll be working on blank experiment. So once you click on blank experiment, a new window appears. Okay, so let me go through the components that we have here. So on the left hand side, you have the components. At the center, you have the canvas where your experiments will take place. And on the right hand side, you have properties. So today we'll be working on problem statement, which says that we need to find out the income of an individual whose data we don't have in a system. Now let's go on to the component part and find the best data set that can suit our problem statement. Okay, so we see that we have list of data sets in our samples. So the very first data set is adult census income binary classification. So we'll select the data set and drag it over to the canvas. But before that, let me give a name to our experiment. So we'll give the name as income prediction. Now once you click on adult census income, you can see there is a circle. Press right click and 4 options appears in front of you. The first one is download, the second is visualize, third is generate access code, and the last one is notebook. Since we need to visualize the data set, we'll click on visualize. So once you click on visualize, a new window appears. On the left hand side, you can see there are 32,000 rows and 15 columns that we have in our data set. But before that, let me go through all the columns that we have here. So the first one is age, which tells you about the age of a person. Then is work class. So this gives you an idea whether he's a government employee, is he working in a private sector, or is he a self-employed. Then is FNL-WGT, which is the sample weight of the field. Then is the education. So education is basically telling us about his highest degree. Whether is it bachelor's, is it high school grad, or is he a master's. Then comes education number. So this gives you an idea of the number of years he took to complete his education. Then is marital status. So this is telling about a person's, is he married or whether he has never married. Then is occupation. So occupation is actually important while finding out the income. So if a person is a manager, there are chances he will be earning more as compared to others. Then is relationship, whether he is a husband, is she a wife, or has he never married. Then comes sex, whether he's a male or the female. Then is capital gain, capital loss, hours per week. So this gives you an idea of number of hours a person is working in a week. Then is native country. So income varies from country to country. So getting to know about the country is also very important while predicting our model. And at the last, we have income. We see that the income column is divided into 2 halves, which is above 50 and below 50. So there are 2 distinct values in income group, and in cases like these, we make use of classification algorithm. Now let's go to the next part, which is where we will define the fields that we need to have for our prediction. So what we do here is we select the column. So on the search bar, when you type column under manipulation, you get a list of options. From that, you select column in dataset and drag it over to the canvas. Now connect your dataset with select column in dataset. Now under this, you can see there's a caution which says that value required. So you go under properties and select launch column selector. So once you select launch column selector, window appears. So this gives you a list of all the columns that we have in a data set. So the very first column that we have here is age. So age is actually important in understanding the income of a person. Then comes work class. So the background of a person, whether he's working in a government employee or is he a private employee, is also important for prediction of income. Then comes education. A person who has a master's degree has more chances of earning than a person who has a graduation degree. So education is also an important field while predicting our income. Then what comes next is occupation. After that you have country. and at the last we'll work on income. Now when you press next, you get back to the same window. So now that we know the fields that we're working on, our next step is to find the algorithm that best suits our model. Okay, so now that we know the fields that we have to work on, our next step is to find the best fit algorithm for our model. So what we do here is we look at the list of algorithms that we have. But before that, we know that our target value is divided into two classes. So the algorithm that we'll be working on is a classification algorithm. Now Azure provides few classification algorithm like logistic and decision tree, two-class boosted decision tree. So we'll be working on two-class boosted decision tree because this gives you a high accuracy rate. Now let me give you an idea of why two-class boosted decision tree is taken over all the other classification algorithm. So what happens in two-class boosted decision tree is for every node that we have here, the accuracy is calculated. And once the accuracy is above our required accuracy, then only it moves on to the next nodes. So this gives you a high, so the prediction value here becomes more and more towards a higher side, so that the overall model will give us a very high accuracy. Okay, so our next step here is to train the model. So on the search bar again, just type train, and under train you can see there's an option called train model. So drag the train model over the canvas and connect the two-class boosted decision tree with this. Now you can see that it says that it requires a value or a data, which is obvious because it does not have any data to work on. So our next step here is to split the data. So on the search bar, when you find split, it gives you an option called split data. When you drag the split data over a canvas and connect it with your column data, it asks you for the split percentage. So you split the data into training and testing. So 80% of data gets into the training model and 20% goes into the testing model. So what we do next is we connect 80% of training data with the train model. But you see there's a value required. This is because the model is not aware of the column it needs to train on. So what we do here is we go on launch column selector and select the column. So we need to work on income column. So when we select column and press enter, we see that the question mark is gone. Now our next step is to find the score of the model. So what score does is it gives you the prediction value of the model. Okay, so when you connect your train model with the score model, you again see a caution sign here. This is because it does not have idea of what it needs to test on. So you connect your testing data with your score model. So our last step here is to evaluate the model. So on the search bar, when you type evaluate, you get an option called evaluate model. You drag the model here on the canvas and connect it with the score model. So your model is now complete. Now our next step is to save the model and run it. Now once our program is executed, click on evaluate model. Once you click on evaluate model and press visualize, a window will appear. This shows you the performance of the model. You see that the accuracy is 79, which is considered to be good. Now let me go through all the other options. You see there is an option called positive label and negative label, which has been assigned values of above 50k and below 50k respectively. Now let me tell you what these values are. So this part is known as the confusion matrix. So of all the values above 50k, true positive give me value that are predicted correctly and false positive give me value that are not predicted correctly, which means that 6 out of all the value that we have in positive label, 667 have been predicted right. That is, they have their salary above 50k, and 422 have been predicted wrong. Similarly, there out of all the people that we have, 840 have been predicted wrongly. That is, they have salary of above 50k but have been predicted below 50k, and 4091 have been predicted correctly. Now this is used to find the accuracy of the model. So what you do here is you sum the true positive with true negative and divide it by false positive, false negative, true positive and true negative, and then you multiply it by 100, and that's how you get your accuracy. Now let us go back and run this service over the net. So when you click on set a web service, you see predictive experiments. Click on predictive experiment. Now our next step is to connect a web service input, that is the entry point, with the score model. So what it does is, once the program is over the cloud, it directly connects to the score model and shows us the output. So you don't have to go through all the processes now because the machine is automatically learning. Now you save this and press run. This will execute the entire model. So once this is done, all that is left with you is to deploy web service. So once you click on deploy web service, it will take you to the dashboard. So you see an option called test. Once you click on test, it will take you to a window where it will ask you for values. So let's just say that I have a value of person age 35. Let's say he's working in a government. His education is bachelor's. Then his occupation is manager. His country is US. So once I press next, it will give me the predicted value telling me that he will be earning 50k with a precision rate of 0.12. So this is how you make use of machine learning in Azure.
The service Azure Active Directory. So firstly, let's ask the most important question. What is Azure Active Directory? Now, here we are in a situation where we have two colleagues having a conversation with each other. So one of them complains that he is finding a hard time managing multiple user logins at the same time. His friend suggests that he has a solution, that the company start using Azure Active Directory. He says that with Azure AD, they'll be able to handle multiple user logins without any issue. So just like the question in all our minds, the friend asks, how is Azure Active Directory going to help us? So to help you understand, let's think about a scenario. Now you're an employee working for an organization and you want to use a particular service, in this case SQL database. So you're assigned a set of username and password. Then you want to use another service, a machine learning service. Again, you're assigned a different username and password. And likewise for any number of services that you want to use. So for every service that you're going to choose, you need to be assigned a new username and password. But this becomes a huge issue for the administrator as they have to handle a large number of username and passwords. Now, if you think about a large organization where there's more than 1,000 people working, you can understand how much of a hassle it's going to be for the administrator. At the same time, it's also a really difficult thing for you to remember that many numbers of username and passwords. It's difficult on the user as well. And that's where Azure Active Directory helps. Now, here's a scenario where we're applying Azure Active Directory. Now, you're an employee, you want to use a particular service, and you're assigned a single username and password. And with this username and password, you can access all the services that you want. So there's only one set of username and passwords that you need to remember. You can use any of the services that you want as long as the administrator has given you access to it. So what is Azure Active Directory? Now, Azure Active Directory is a service that falls under the identity domain. It allows multiple users and is a cloud-based directory and identity management service. Now, here's an ideal scenario. You're joining an office newly. The admin helps you sign up to whatever services you want, and you can access these services anywhere over the cloud. So now let's talk about something different, Windows AD and Azure AD. Now, Windows AD was the previous version of Azure AD. So now we'll talk about why we needed to change from Windows Active Directory to Azure Active Directory. So what is Windows Active Directory? Now it's an OS directory service which allows you to work with multiple systems, multiple network resources in a unified manner. Now the biggest draw when it came to Windows AD was that it had many layers. Now different layers that did different bits of work. So now let's talk about each of these layers. The first layer is ADDS, or the Windows Active Directory Domain Services. Now each layer, as I said before, has a different role to perform. ADDS allows admin to manage information relating to user logins and other details like when they signed up, how much they're using, and things like that. The next layer is ADLS, or the Azure Data Lake Storage Services. This layer is for allowing you to store any amounts of data of any type or size. Then you have the ADFS, or the Active Directory Federation Services, where you're given a single option for sign up with which you get access to all systems and applications. Then we have the fourth layer, the ADCS, or the Active Directory and Certification Services. This enables administrators to customize services and then be able to manage and issue public certificates. And the final layer is ADRMS, or the Active Directory Rights Management Service. And this is used for data protection. Now, here's where Azure Active Directory changed the whole game. This means that there's a large number of layers that administrators need to take care of. Now, how about there was a solution for this? And Azure AD is that solution. Azure Active Directory integrates all these 5 layers into 2. And these are the Windows Azure Active Directory, or the WAAD, where it combines all the problems when it comes to identification management, which is almost all 5 layers taken into one. And the Windows Azure Access Control Service enables the federation or the division of all these services of an organization. And by division, I mean assigning each of these services to these users. So that is taken care of by the Windows Azure Access Control Service. Hence, Azure Active Directory is able to simplify a lot of the problems that Windows Azure Active Directory had. For example, the application Office 365 uses Azure Active Directory to manage user identities. Here's how. Now, you're an employee who wants to access one of the Office 365 services, which could be Excel, PowerPoint, Microsoft Word, or something like that. So you go talk to the administrator and he gives you access to these services with the help of a single username and password. Now, as long as you have this username and password and the administrator has given you access to it, you can use any of these services. So who's the service audience? Who is using the Active Directory service? Now, there are 3 types of audience when it comes to Azure Active Directory. The first one is IT administrator, the second one application developers, and online customers. So the IT administrators, their main emphasis is to ensure that the sign-in takes place. They take care of all the sign-in procedures. They also solve issues when it comes to authentication. For example, to authenticate a particular user, the problem is solved by the IT administrators. Then you have application developers who use these services to develop applications. And with this, they have an easier time developing applications as all these resources are easily available. You have online customers who make use of services like Office 365 and other CRM services and have all their demands catered immediately. So now let's have a look at how we can use Azure Active Directory to provide access to a particular individual. So if you log into the Azure account, this is what you see, or you go into Active Directory, a list of all the people who are using or have been given permission to use resources from Azure. Okay, now we're going to create a profile. We need to set up his name, which is John, and second name, Jacob. Now for properties, we need to determine the source of authority, which is already the Active Directory, so that's fine. We can select a group or add them to a particular group if we feel like it. Now, if we add them to a particular group, it means that they have access to all the resources that everyone in the group has access to earlier. So we'll do that later. We'll select their directory role, or we can select it here if we need to. It could be user, administrator, or a limited administrator. And now we'll set up a password. So we already got one and we'll create. And that's it. We have created a user. Now we'll go to their profile. So what we can see here is that you have access to every bit of detail related to this account. So you have the name, your first name, the username, the object ID, job info, everything. You can even have other details like how often they've signed in, when did they sign up. You can check their password, you can reset the password, delete their account, and so much more. Now we can even add a directory role, which we saw earlier. And now let's add this person to the admin group. So, he gets access to all the services that those people have access to. Select. That's it. We've added them. Now the other things that you can see here, there are applications, licenses, devices. These are all restrictions you can add or remove, like which device you can use the system through or with and stuff like that. So that's it. And with that, we've created a user and given him access to certain services. We are going to talk about another important Azure service, Azure Data Factory. Now, why should you be interested in Data Factory? Now let's consider a scenario. So here we have 2 colleagues having a conversation with each other, and they say that the data that they're generating from their applications or products is increasing exponentially. Now, considering that this data is coming from a number of different products, it'll be a bit of a task to analyze and store all of this data. So he wonders how they're going to manage that. His friend suggests that they use Azure's Data Factory. Now, what does Azure's Data Factory actually do? First, it stores data with the help of the data lake storage. Now, any kind of data can be stored in the data lake storage. Then you can analyze the data, you can transform the data with the help of pipelines, and you can publish the organized data. You can visualize the data with third-party applications like Apache Spark or Hadoop as well. Now, what exactly is Data Factory? So now let's have a look at what exactly is Data Factory. Now, Data Factory falls under the identity domain of services in the Azure catalog, and is a cloud-based integration service. Basically, what it does is it works on your data, it stores your data, it orchestrates and automates the movement or transformation of data. It works heavily on the data that you store. Now, let's see how it actually works or how the flow of its processes are. Firstly, we have the input data set, which is nothing but the data that you have within your data store, the one that you need processed. Then you pass this data through a pipeline. Now, what does a pipeline do? A pipeline basically performs an operation on the data that transforms it, which could be anything from just data movement or some data transformation. Now, data transformation is possible with the help of USQL, some stored procedures, or Hive. Now, after this is done, you get an output dataset. Now, this output dataset will contain data that is in a structured form because it's already been transformed and made structured in the pipeline stage. Then it is given into linked services like Azure Data Lake, block storage, or SQL. Now, what it does is these store information that is very important when it comes to connecting to an external source. Now, this is, if you wanted an example, how in an SQL server you need to mention the source and destination of your data. Now, for example, consider an SQL server. So you need a connection string so that you can connect to an external device. You need to mention the source and the destination of your data. This is how the link services work. And finally, you need a gateway. Now, a gateway basically connects your on-premises data to the cloud. So you do need a client installed on your on-premises system so that you can connect to the Azure cloud. And finally, you have the cloud. Here what happens is your data can be analyzed or visualized with a number of different analytical softwares like Apache Spark, R, Hadoop, and so on. So all this time I've been mentioning that data lake is a very important part when it comes to Azure Data Factory's proper functioning. So now let's talk about what exactly is data lake. Now, data lake is a data storage or a file system which is highly scalable and distributed. It is located in the cloud and works with multiple analytics frameworks, which is external frameworks like Hadoop, Apache, and so on. So now let's have a look at it. So first you have your output data set, which is data from the mobile, video, web, social media, so much more. It is sent into the Azure Data Lake store, and then it is provided to external frameworks like R, Apache, and Spark so that they can be worked on. Now, there are two main concepts when it comes to data lake storage. So one of them is storage and the other one is analytics. Now, storage is of unlimited size. It can be petabytes, terabytes, gigabytes, and so much more. It stores a wide variety of data. It could be unstructured or structured data, and it can store really large files. And another concept when it comes to data lake is analytics. Now, how it works. Now, here are two examples of how analytics works when it comes to data lake. Now, when it comes to analytics, you can monitor and diagnose real-time data. For example, data that you're getting from vehicles or buildings. These can be used to optimize how they work, respond to certain events, or generate alerts in case something goes wrong. Then you can also identify fraudulent transactions on your credit card, or you can identify the geographical position of your card. Perhaps monitor how many transactions have been taking place on that card, and so on. So now we're going to have a look at how we can use the Azure Data Factory to move data from an SQL database to a blob storage on the cloud. So here's what we're going to do. So first off, to make a database, what you're going to need is software known as SSMS. So you can find it on Google. It's called, you just need to Google it, SSMS. The first link you can take here, and there you have it. So you just need to click here and download the file. So I've already downloaded the file. So basically this is used to create a database which we'll be transferring to the blob storage. So this will take about, depending on your computer speed, pretty long or little to no time. I've already downloaded it. The process is very simple. Just directly go on saying yes, yes. And finally, once the installation is done, here's what we're going to do. We should go into the dashboard of Microsoft Azure. We need to create a data warehouse. So we'll go into all resources, create resource, go to database, and select SQL data warehouse. There we have it. Now, it's very important that you remember the names of the service of everything that you're going to write here, because each of these become very important later on. So I've already set up a possible set of names. YouTube, it's free trial. The resource is already created. A blank database. The server, we need to create a new one. So we'll name it as YouTube server. YouTube admin. as the server admin login, the password as alright, the location does not matter. Okay, that's done. Now here the server is done, and here we need to change how much you want the lowest, how much computation you want, how much the workload, how important your workload is. So we'll put it at the lowest since we don't require much. We'll apply, the rest is normal, and create. So now we're creating an SQL data warehouse, so we'll wait. So now the deployment is done, so we'll go to the notification and go to the resource. Here, now this is done, so we'll go to the SSMS, which I've already opened here, and then go here and copy this, paste it here, SQL authentication, login, which details we have already stored here, which is admin, YouTube admin, and the password, which is also given there. Right, go to options, we go to the database name, which is YouTube, everything else is there. We need to change it to TCP/IP and connect. We sign in. We'll add the password. Again, we're going to sign in now. Right. So now that that's completed, you can see that this is what will pop up. So this is the name of the server we've given, as you saw earlier. You go to databases, and here you have the YouTube database that we just created. Right click this and add a new query. I already have a code for this program. It's a very simple program, so copying and pasting this. Now, if you need the code for this program, let us know in the comments below. It's very simple. What we're doing is creating a table called demo tab with first name Clark Kent and last name is Bruce Wayne, and the table that's created will have these two rows. So now we're going to execute this. And there you have it. 2 rows have been affected. So now let's have a look at our table. Execute this line, and there you go. The table's here. So now that this is done, we're going back into Azure, and we need to create a storage account. So that's where the blob storage is going to happen. So we're going to storage accounts and click on add. So here it's a free trial. The resource group is YouTube. Storage account name is store. That's all. Okay. US performance is standard. General purpose you can do locally since we don't need it to be very reliable, at least for this one. Advanced is fine. View and create. That's done, and we create. Now we'll wait for the deployment to finish. And that's it. The deployment is done. So we'll go to the resource and go to blobs. So this is where the storage is happening. We need to create a blob. Simply blob, which does not exist. And okay, it has been created. Now for the next bit, we need to create the data factory now. So we go to all services, search for data factory. We press add. So here we'll free trial, use existing, which we have YouTube, East US, and create. So now we've created a new data factory. Now we'll wait while it's being deployed. So now it's created. So we'll go here, and here we click on copy data, and this opens up. We'll name it. Now description, run once now. Once now, okay. Right, so we press next. So we need to connect to a data source. So what you need to do is select Azure SQL data warehouse. So one second, go to previous. Here we select Azure SQL data warehouse. Go here, search for source, Azure subscription, free trial, here YouTube server, and the database is YouTube. You also need to provide your username and password. I've saved it here. YouTube admin. Right. Okay, now we can select the table, which is demo tab. Next. And now for our destination. So where are we going to connect this to? We're going to Azure Blob Storage. Next. Destination. Job subscription free trial. And simply store. Now we need to name our storage path. Next. All of this can be passed on. So here's what we're doing. We're copying whatever is inside this to the Azure Blob Storage. That's what's happening right now. All of that is set. And next. It's validating and we'll wait now. It's registering connections, creating database, and in the end it's creating a pipeline. So you can monitor the pipeline from here if you feel like it. Now, here's what we're going to find. So here's the visual representation of what's happening. It's being copied into the blob storage. Now let's have a look if it's actually worked out. We go to our database. We'll go into storage accounts, simply store, go to blobs. We've created a new one, and there you have it. So based on the container that you've named there, it's created a new one here. So actually I had earlier created the name called simply blob, but as you can see here, as long as you name a container, it will create a folder inside which you will find your particular thing that you copied. And that's it, you've copied data. Similarly, you can do a number of multiple operations on this container, on the pipeline you just created with the data factory. And that's that. And with that, we've reached the end of another video. I hope you guys found this informative and helpful.
We are going to learn about the Azure Virtual Machine. So, without further ado, let's get started. Before getting in depth, let me tell you what's in store for today. First, I'll be talking a little about Azure. Next, I'll start off by explaining the Azure Virtual Machine. Then, I'll be focusing on few benefits of Azure Virtual Machine. Moving forward, I'll be going in depth with the Azure Virtual Machine components. And finally, we will be looking into a demo on Azure Virtual Machine. All of us may have heard of Azure at one point of time, but what is Azure? Let me explain. Azure is a cloud service created by Microsoft for building, testing, and managing applications and many services through the Microsoft data centers. The Azure hosts web applications over the internet with the help of these data centers. Azure is very flexible. It gives an option to have the functionality as required. You can pay as you consume, switch to Azure, and accommodate the business fluctuations. There is no need to worry about the infrastructure all the time. Azure is very reliable and has 24/7 tech support. Azure offers pay-as-you-go pricing and hence it is very cost-effective. Staying online all the time ensures customers or users trust. Azure supports backup and disaster recovery tools. Now we know what Azure is and its key benefits. Let's now move on to Azure Virtual Machine. Before that, let's consider a scenario. Rachel had to host 10 virtual machines at once for a project. There was an issue when her computer RAM was not compatible with the instances. The computer RAM was only 8 GB and the instances that required were 10 GB. Then she says, I wish there is a service that's cost effective and also provides extra RAM memory. One of her colleagues heard this and he comes up with an idea. He says, can we use Azure Virtual Machine? It has a pay-as-you-go pricing and has disks for storage. You can pay for what you use and create any number of instances with high storage capacity. Also, if any technical difficulty arises, you can easily retrieve the files through the backup server. So now she's happy and she wants to know more about Azure Virtual Machine. Azure Virtual Machine is one of the wide range of services that Azure offers to create your instance. A virtual machine is a computer file, typically called an image, which behaves like an actual computer. It runs in a window, giving the user the same experience on a virtual machine as they have on the host operating system itself. Multiple virtual machines can run simultaneously on the same physical computer. Each virtual machine provides its own hardware, like CPUs, memories, and other devices. Azure Virtual Machine offers a high range of flexibility and it maintains the physical hardware that runs on it. Let me explain some of the benefits of Azure Virtual Machine. First, we have easy development and test.
Azure Virtual Machine has a quick and easy way to configure the computer that is required to code and test an application. Next, agility and scale. Azure Virtual Machine is agile, and the ability to clone and spin up multiple instances of the same virtual machine allows us to scale services and applications rapidly, efficiently, and very cost effectively. Azure Virtual Machine provides enhanced performance. Demands for applications can fluctuate, so you pay for the virtual machines you need and shut down the unnecessary ones to save the cost. Azure Virtual Machines provide extended data center and can be easily connected to an organization's network. It is easy to set up your redundant infrastructure on Azure, and Azure provides a full disaster recovery site at a fraction of the cost. Furthermore, let me explain Azure Virtual Machine components in details. Virtual Machine comes under the compute domain of Azure. It also offers various services like availability sets, snapshots, disks, images, and many other services like hosts. Virtual Machine can be clubbed with other services like disks, images, availability sets, hosts, and many more. So, the first component and the most important component is the operating system. The operating system creates connections to the remote desktop session host. There are many operating systems available like Ubuntu, Red Hat, Linux, Windows Server, CentOS. You can also set the operating disk size so that the memory is not wasted. The next component is disks. Azure Virtual Machines use attached virtual hard disks for storage. There are two types of virtual hard disks. First is an image. It is a template for creation of new Azure Virtual Machine. Then we have disks. It is a bootable virtual hard disk. All durable disks are backed up by page blobs in Azure Storage. Therefore, the disks inherit the benefits of blob storage, high availability, durability, and many more. The disks are mounted as drives on the VM. The next component is virtual network. Many components operate the virtual machines in a scalable and secure manner. Virtual networks could include equipment such as separate network spaces for internet-facing and backend servers, load balancers, firewalls, and more. Many of these components are deployed into an Azure Virtual Network. Azure Virtual Network provides many features such as subnet, IP address, load balancer, and network security group. Another important component of Azure Virtual Machine is availability sets. If in case there's a slight chance there could be a failure in physical servers, then these come into picture. So in case of such failure, the Azure platform will migrate the failed virtual machine to a healthy host to reconstitute the VM. It is highly recommended to deploy at least 2 instances of the virtual machine, and virtual machines placed on an availability set perform identical set of functionalities. Now that we know what Azure Virtual Machine is, let's look into the demo. In this demo, first we are going to create a virtual machine, connect it, and then create a web server and modify the web server, and finally launch the web application. So let's go ahead into the demo now. So the first step is to log into Microsoft Azure with your credentials. Now let's click on virtual machines and create a new one. So I can put add, and you can use the subscription you want, either pay-as-you-go pricing or free tier. Resource group will create a new one, that is payroll 1. Okay. Virtual machine we can create. I'm going to use VM web 001, and then region I'll be using East US. Then image I'll be using Windows Server R2 data center. Size I'll be using B1MS. Select username root admin, and then password of your choice. And then I'm going to allow selected ports and choose RDP3389, and next. So OS test tab I'll be using standard HDD, and then next. So I can see a default virtual network and a default subnet and public IP as well as default. Then next. You can allow for auto shutdown, but again it's entirely your choice. I'm going to select an extension to install, and I'm going to install Microsoft Anti-Malware. Create, okay. I'm going to create a few tags now. Let's go ahead with it. So I've created 5 tags. Now review plus create. Okay, so everything seems good. Let's create now. So the deployment is going to take a few minutes. Let's wait for it. Okay, so that's done. Now let's go to virtual machine and see our virtual machine. Okay, so it's been deployed. Now let's get into the virtual machine and copy the IP address. Then hit Windows plus R and open MSTSE and paste the IP address and connect. Let's use a different account. You have to use the administrator account that we created before with the same password. Click OK. Now the remote desktop session host opens. The next step is to click on Server Manager and add rules and features. Click on Next. Select role-based or feature-based installation and click on Next. Then select the virtual machine you've created and Next. And then we are going to select Web Server IIS. Next. Next. Okay, so it's already installed on my computer, but you have to install this. Then let's close this and open Internet Explorer. Let's type in HTTP localhost. Yeah, so now we can see the default browser opening. Let's minimize this and let's try it here. Here you have to just put the IP address. I think there's an issue. Okay, so let's add an inbound port. Networking, select networking and add inbound port. Let's name port 80 and add. Okay, so it's added. Now let's go and refresh it. Now we can see the default web browser opening. So the next step is to modify the web browser. Let's go ahead with that. Go back to your remote session host. Let's go to File Explorer. So certain folders are created in the C drive. Let's open that. It would be under inetpub. So this is where the default browser is coming from. Now let's make a new text document. Open that and put hello, welcome to this demo by Simplilearn. Save it, close it. Let's rename this as index.html. So this is a text document, so we need to change that. Okay, let's remove this. Okay, that's done. Now let's go back to our Internet Explorer and hit F5. Let's refresh this. Let's try now. Okay, so let's so it's done. Now let's go back to the previous browser and try. Let's refresh. Yeah, that's done.
The Azure Virtual Network tutorial. Let's look into what's in it for you. So we would be covering why is Azure Virtual Network important, what is Azure Virtual Network is, benefits of using the Azure Virtual Network, components of Azure Virtual Network, that includes the subnet, routing, network security group, why these components are required to be created in the virtual network, and how to launch an instance within the Azure VNet or the virtual network. And then we will be seeing one demo in which we'll create Azure Virtual Network, subnets and network security groups. So first of all, let's look into why is Azure Virtual Network important. So why Azure Virtual Network is required? So somewhere far away at an office, a company was struggling with few challenges. The company got a bigger projects which lead to the following challenges. That includes poor network connectivity, time-consuming process in building network topologies, could not divert network traffic to its destination on time. So these were a couple of challenges the company was facing. So the employees thought that what could be the possible solution to these challenges? And then we require the Azure Virtual Network in that case. So first of all, let's understand what is Azure Virtual Network is. An Azure VNet or a virtual network represents your network or environment to run VMS and applications in the cloud. When it is created, the services and virtual machines within the network interact securely with each over the internet. So virtual network, you can consider it as a virtual cloud, which is basically kind of a cloud space virtually assigned to the users or to the organization, which they can dedicatedly use for their purpose. So for example, if you have to create some instances or virtual machines onto the Azure cloud and you want to connect it with the on-prem servers, for example, then you might require the virtual network in that case. Let's assume that those instances that are created in the virtual network require the range of IP addresses that you want to allocate to them, and that is something you can customize using the Azure Virtual Network. How do you want that the traffic should be routed to your instances in the virtual network, how the firewall securities should be applied? Everything the end user can control in the virtual network. So it seems like that you are working in your own data center. Ideally, you would be working onto the Azure cloud using the virtual network. Now, what are the advantages of using the Azure Virtual Network? So a couple of them are, it provides an isolated environment for your application. So as I said that, it seems like that you are working in your on-prem environment. That means within your data center. But ideally, it is a virtual space that is allocated to you, which is a kind of an isolated environment that is specifically designed for your task and the activities. Generally, a subnet in a VNet can access the public internet by default. So we create a subnet inside the virtual network which can access the public internet. So there is a public network connectivity that is enabled in the virtual net so that a subnet which will be created in the VNet can be accessed. Traffic can be easily filtered from different resources. So you can have some control lists defined, you can have some security groups created, and how do you want to allow the traffic onto the servers or the application? That is something which you can control. It is a highly secure network, and the security groups and the policies are basically implemented by the end user. So you can design how the security should be implemented.
high network connectivity, so you have a higher bandwidth as compared to the normal internet connection you might be having in the data center. Compared to that, you use the Azure network only, which gives you the higher network connectivity. It builds sophisticated network topologies in a simple manner and which is easily manageable, as well as there are less troubleshooting issues that we would encounter. Now, what are the components of Azure Virtual Network? One of them is the subnets. Then you have routing. Then you have network security groups. Now, what do we mean by subnets? The subnet is one of the major or a prime important component in the virtual network. So what you have to do is, first obviously you would be creating a virtual network. Inside that you can create the subnets. Subnets, you can consider it a logical partitioning or virtual partitioning inside the virtual network. Subnet lets user segment the virtual network into one or more subnetworks. For example, let's assume that you're working in an organization, and in the organization there are different departments. For every department there should be some set of IP addresses that you want to allocate to the machines that the employees are using. Or all the departments should be isolated. That means that they should have their own network IDs and the network addresses allocated to their machines. And in that case, what you would do is you would create the subnets and the subnet IDs that would be allocated to those departments. These subnetworks can be separated logically, and each subnet consists of a server. So what you do is, when you create a subnet, you can create a server or an instance inside that subnet. And how do you want to give an access to that instance depends on criteria or the requirement. Hence, a subnet can further be divided into two parts, one as the public subnet and the other one as the private subnet. These are the naming conventions of the subnet. Then how do you want to give the internet connectivity depends on how the public subnet should be interacting with the internet. And for the private subnet, as the name suggests, that the internet is blocked. So that means it is completely isolated in the virtual network. The private instances, though, if you want that any instance created in the private subnet should have the internet connectivity or an access, you can primarily go with the NAT gateways in that case, which is a network address translation or kind of a translator which converts the private to public and vice versa. And that would actually enable the internet connectivity to your subnets. Then in the public instances, they can directly access the instance. As the name suggests, public instances, that public subnets, that means they have the direct internet connectivity. Next component is routing, and the routing is primarily a routing rules, you can say, that are applied, and those are actually applied to the routers only. So since on the cloud we cannot have a direct router access, and hence using the routing as a component, we can define some routing rules which are directly applied to the router in the infrastructure. It delivers the data by choosing a suitable path from source to destination. For each subnet, Azure Virtual Network automatically routes traffic and creates a route table. When you create a virtual network, automatically a route table is created, and that basically is required to route the traffic, and that can be used by every subnet. That doesn't mean that you only have to create a single route table in the virtual network. You can have multiple route tables also created, which can be associated with different subnets as well. Then you have the network security groups. It is kind of a firewall that protects the virtual machine by limiting the network traffic. It restricts inbound and outbound network traffic depending upon the destination IP address, port, and the protocol. So it is basically the network security group sits on the instances and or virtual machines, and they basically define that how the traffic should be reaching to the ports onto the virtual machine. So how do you want to open up the ports, and for which IP addresses you want to open up the ports? That is something the end user or the administrator has to specify or design. So they act as a kind of a firewall rules only that protects the virtual machines. So how to launch an instance using Azure VNet? So first of all, you have to create a virtual network. So virtual network act as a container for subnets. So first thing is that you would be creating a virtual network. Then you would be creating subnets which are consider as a subset within the virtual network. So cloud instance is included in the subnet. So first VNets are created, then the subnets are created, and then you configure the properties in the security group. Have a look at this in detail. Now, with respect to the virtual network, what you need to do is you have to create a virtual network in the Azure cloud. Then you have to create subnets into each virtual network, which is kind of a subset of a virtual network. So you can create one as a public subnet, the other one as a private subnet, for example. Now you have to assign instances. So when you create an instance, you have to specify that what is the virtual network, for which virtual network you're creating an instance. Within that virtual network, you have to select that on which particular subnet the instance should be created. And then connect instance to a relevant network security group. So attach your network security group to the instances, and based on the properties or the rules that are defined in the network security group, that will be applied to the instances within the subnets. Finally, configure the properties in the network security and set the policies. As a result, you will be able to launch your instance on Azure within the virtual network. Now we will be seeing one demo that how we can create Azure Virtual Network subnets and the network security group. So just be there to watch our demo on the Azure Virtual Network. In today's session, I would be showing how you can create the virtual networks onto the Azure. And for that, you require the credentials on Microsoft Azure, and here you can see on my screen that I have already logged in into the Azure console. Now what you need to do is, in order to search virtual network, you can type and search in the dashboard, in the search bar, with respect to the virtual networks. And here you can find the virtual network and the gateways. So what you need to do is you just have to click on the virtual networks, and then it will give you the options to add the components inside the virtual networks. So let me first open up the virtual network. Right. Now, in theory, we discussed that the virtual network comprises of multiple components and subcomponents. So primarily is that first you have to create a virtual network. Then you have to assign the IPv4 CIDR block to the virtual network. And then you create the subnets inside the network, which is a subset of the virtual network. Along with that, you define the routing rules. And likewise, you create the instances inside the subnets that will be part of the virtual networks. So that's what we are going to do in this demo. So I would be adding up a new virtual network. So you can see here there are already two virtual networks that have been added. One is the demo VNet, which is by default. So when you created the Azure credentials, the demo virtual network was already created by the Azure, so that it can provide you the default settings. And then the test one has been created by me, and that's the customized one, or you can say a non-default virtual network. So I'm going to add another VNet and would define the name to it. So let's wait for the details to appear. So here you have to define the virtual network to create. Obviously we will be going with the free trial only. And then you have to create a resource group. So what is a resource group? It is primarily a collection of resources that share the same lifecycle, permissions, and the policies. So if you have a resource group created, you can use it. Otherwise, you can create a new resource group. So I already have one, that is the demo one. I would be using that. In the instance details, you have to specify the name of the virtual network. So these are certain parameters that you have to go with while defining the name. So let's say I put something like test VNet as the virtual network that I want to create, and that is, you have to select a region where you want to get that created. So these are the available regions that you can select. I would go with US East US only, and then we have to define the IP addresses also. So in the IP addresses, the CIDR blocks are allocated to the virtual networks, and that becomes a fixed IP address for that VNet. So what you can do is you can specify a range of IP addresses. Now whenever we talk about a virtual network and the IP addresses, we primarily focus on the private IPs only. So this is the private IP that we are actually talking about. So I can reserve some IP address CIDR for our VNet, and that is the range of 40.0.0.0/16 I'm going to reserve. So now we'll create one subnet and we'll name that subnet. So as we discussed, that subnets are the subcomponents of the VNet. So here you can see we have already created one subnet with the name public subnet. So likewise we can add another subnet also, and let's name it to something like demo subnet, right? And the subnet should have the IP address range, and that IP address range should be part of the VNet only. In V18, so same subnet address range you would be defining in the subnet as well. So that will be 40.0.1. or we can select 2.0/24. The rest of the things would be default. We are not attaching any route table as of now. So just click on OK. And here you can see that the subnet is created. Now once the subnet is created, now we are going to create a virtual machine inside that subnet. And for that, we'll go to the search bar and here we'll type virtual machines. Now we'll create a virtual machine in the same VNet, that is the test VNet, and inside the demo subnet, so that our virtual machine gets the private IP address from the subnet that has been created in the VNet itself. So what you need to do is you have to open up the virtual machines, click on add, and here you should add a new virtual machine. So you should select the name of the virtual machine and the network details where we would be defining the VNet as well as the subnet where the virtual machine should be created. So in the subscription we'll go with the free tier, and in the resource group we'll go with the demo that has already been created. We'll put a virtual machine name, something like test VM, and the rest of the things will be default. So we'll quickly skip the disk check also. Now in the networking we would be selecting the test VNet as our virtual network, and in the subnet we would be selecting the demo subnet. So that is the recently one added in the test VNet, and we want that our virtual machine should be part of that subnet only. Now obviously since we are creating a virtual machine, so it should be part of, it should have the public IP also assigned, since from the public network we need to access those virtual machines. So we'll keep it enabled, right? And the next would be the default settings that we are going to proceed with. So let's review all the configurations and then create your virtual machine. So here you can see that our virtual machine has been created, validation has been passed, and it takes a couple of minutes to get that updated. So let's wait for a few more minutes so that our virtual machine is ready. And primarily what we want to look into is that our virtual machine is created in a correct VNet, and it gets the private IP address from the subnet that has been part of the VNet which has been defined in the creation of a virtual machine. So let's wait for a couple of more minutes and we'll look into the status of the VNet. Now you can see here our test virtual machine has been created. Now what we wanted to look into is that our virtual machine is created in a correct subnet or not, and that is something which we can validate by checking the private IP address. So it got the private IP from the range of the IP address that we have specified in the subnet. Now in order to access this particular virtual machine, you have to use the public IP, since we have to access it from the internet. So from the private IP, this virtual machine will not be accessible. So that's the reason that when we created a virtual machine, we allocated the public IP address also for this instance. So that is with respect to the virtual network and the demonstration on it, and how we can create a VNet and the subcomponents of the VNet, how they are associated or interlinked with each other, and that actually creates a kind of an isolated environment on the public cloud, which gives you the understanding that you can work into just like an on-prem environment only.
Today we will discuss what should an individual learn in the year 2021. Let's wait for an ample amount of time so that few more people can tune in. By the time, please allow me to tell you that we have daily updates on multiple technologies. So if you are the tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and hit the bell icon so that you can never miss an update from our end. So we have a few more people now. Hi everyone, welcome to Simplilearn. So without further ado, let's get started. Back in the 2000s, organizations were utterly dependent on purchased servers for their IT infrastructure. These servers not only came with limited functionality, but were also very expensive. The traditional way of storing and managing data was costly and complicated. It required a massive amount of hardware and complex software to run. All these issues were resolved using cloud computing. Rather than owning their computing infrastructures, organizations were able to scale up or scale down resources based on the requirement. Companies providing these computing services are called as cloud providers. According to C# Corner, the two popular cloud providers in the cloud market are Amazon AWS and Microsoft Azure. Now, let's take a step back and talk about a question. What should an individual learn in the year 2021? Amazon Web Services or Microsoft Azure? Though this question is tricky, we need to understand which cloud provider is the best option to choose. Now, let's take a brief look at both of these cloud providers. Amazon Web Services is an evolving cloud computing platform that offers various services such as compute power, storage, database, content delivery, and other resources to help business scale and grow. AWS services are provided based on a subscription basis. Similarly, Microsoft Azure provides a set of cloud services to design, create, and monitor applications on a network. Talking about the general features, Amazon Web Services was established in the year 2006. Today, it holds a market share of 31.7%, whereas Microsoft Azure was started in the year 2010 and now has a market share up to 16.8%. Amazon AWS is the world's most broadly adopted cloud platform. It offers up to 165 services globally. These services are used by millions of companies like Spotify, Netflix, Facebook, BBC, etc. Talking about Netflix, the company moved its IT operations to AWS in the year 2009. AWS was able to solve the company's scalability and data management issues. Azure offers several services in various categories, including artificial intelligence, analytics, containers, IoT, and many more. These services are used by many famous companies like Accenture, LinkedIn, Stack, eBay, and Samsung. Accenture chose Microsoft Azure to boost productivity and provide better security to its employees. The AWS pricing model is based on an hourly basis. With AWS, every individual pays only for the services that are required for his work. Every person only pays for the services he consumes. Azure pricing is charged on a per minute basis. The payment system is very simple and doesn't involve any long-term contracts. Microsoft Azure is free of upfront costs and cancellation fees, and only users pay for the resources they consume. With Azure and Amazon AWS, there are no additional costs or termination fees. Moving on to the next factor, let's talk about availability zones. Availability zones are isolated data centers with independent power and networking. These zones protect applications and files from data center failures. In total, AWS has nearly 77 availability zones within 24 geographic regions around the world. The company plans to establish 9 more AWS availability zones and 3 more AWS regions in Indonesia, Japan, and Spain. On the other hand, Microsoft Azure has many isolated availability zones. These zones are located within an Azure region, and they provide fast network connectivity. Azure has 44 availability zones around the world. The company is planning to launch 12 more zones. Now, after discussing the availability zones, let's talk about the services. The services that I am going to compare here come under the following domains: compute, storage, database, security, and finally networking. AWS and Azure provide a wide variety of services with low migration costs so that every individual can shift his or her current traditional infrastructure to cloud platform very easily. AWS EC2 is a suitable example of compute services. EC2 is a web service that aims to make life easier for developers by providing secure and resizable compute capacity in the cloud. It can be integrated to several other services like S3, IAM, CloudFormation, etc. Azure has a small service called Azure Virtual Machine Image. It helps the developers to develop and design identical virtual machines in the matter of minutes. Azure virtual machines are becoming more popular among IT infrastructures. These machines let an individual create and use virtual machines in the cloud as IaaS or infrastructure as a service. Virtual machines can be created using Azure Portal, Azure PowerShell, and ARM templates, Azure CLI or Client Software Development Kits. Next comes Amazon S3. It is the best example for storage service. Simple Storage Service is an object storage service designed to store and recover any information from anywhere via the internet. Amazon S3 facilitates storage through a web service interface. The service provides 99.9% durability and 99.9% availability of objects. It has the capacity of storing computer files up to 5 terabytes in size. On the other hand, Azure provides a similar service called Blob Storage Service. This service provides a large amount of storage and is highly scalable. It stores an object in the tiers depending on how often the data is being accessed. Blob storage supports widely used frameworks like Java, .NET, Python, and Node.js. It is the only cloud storage service in Microsoft Azure that offers a premium SSD-based object storage tier for low latency networks. AWS provides a secure cloud platform where every individual can manage and deploy their applications. Compared to the on-premises environment, AWS security offers a high level of data protection at a lower cost. For security purposes, IAM is a suitable service. AWS Identity and Access Management is a cloud service that controls and manages AWS resources securely. It has no upfront cost, also gives a facility to create and maintain services within a specific set of users on your AWS resources. In Microsoft Azure, Azure Active Directory, or in short also called as Azure AD, is a web service which provides MFA, multi-factor authentication features to users in order to protect their data from cyber attacks. Next is Amazon RDS. It is a web service designed to simplify the setup, operation, and scaling of a relational database. It is simple to set up, use, and scale when required by users. It provides inexpensive and resizable capacity and automates several tasks such as hardware provisioning, database setup, patching, and backups. On the other side, the Azure SQL database automatically updates and backups data in order to focus on the development of applications. Not just that, it also manages database services and responds to client requirements. Client requirements such as scalability of a service, data backup, and high availability of database. Similarly, these cloud providers have plenty of services that help users build and deploy their applications effectively. Moving on to the next topic, let us focus on integrating AWS and Azure with open source tools. Now, we will explain how to build a pipeline using Jenkins along with one of the services of Amazon Web Services, that is the EC2. In this integration process, we have a sample Python application called as a Docker file. This Docker file will consist of a Python base image. The Docker file builds a pipeline in order to create a Docker image upon pushing the code to the repository. Later, the new image is used to start a new AWS service on an ECS cluster. Now, let's have a look at how the integration of open source tools happen in Azure. In your Azure Cloud application, DevOps tools like Docker, Maven, and Jenkins can be integrated. In case you want to integrate the Jenkins pipeline, go to Project and create a subscription, followed by Jenkins. You can specify the required filters based on your requirement. Then choose your endpoint for Azure DevOps to communicate with Jenkins. So that was all about Amazon AWS and Microsoft Azure. Both AWS and Azure are honored to be on top of all other cloud providers. Both provide all necessary features like scalability, high availability, and security. But the moment I hear about choosing the best one, I have to say that all that depends upon the individual business needs. Both cloud providers are the certified ones that hold immense value in the current cloud service market.
Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website, along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software-as-a-service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS Cloudfront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management management service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and Express Route. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
Azure interview preparation session. Knowing Azure is one thing, having worked on Azure is another thing, and being able to answer interview questions in Azure is a totally different thing. Although one helps the other, it's still different skills. And our aim through this video is to prepare you with common product and scenario-based interview questions. So why wait? Let's get started. A common cloud interview question is, what's the difference between SaaS, PaaS, and IaaS? We all know that a software as a service is thin client model of software provisioning, where client in this case usually is simply a web browser providing the point of access to softwares running on the servers. Now, SaaS is the most familiar form of cloud service for customers. SaaS moves the task of managing software and its deployment to third-party services, meaning the vendor actually gets to manage all that. So SaaS is software as a service involving applications being consumed and used by organizations. So it's generally using an application, and usually organizations pay for their use of this particular application. Now, some examples of SaaS would include Office 365. Salesforce is another very good example of SaaS, and a lot of Google apps and storage solutions like Box and Dropbox are a very good example of software as a service. Talking about platform as a service, or PaaS, it actually functions at the lower level than SaaS. Now, typically it provides a platform on which software can be developed and deployed. Now, here we develop the software, we deploy the software. Now, PaaS actually provides an abstract of much of the work dealing with servers and giving client an environment in which the operating system and the server software and the hardwares and the network are managed and taken care. In other words, with a platform as a service, all the things that I've mentioned, like the servers, the server software, the hardware, everything is managed by the provider, and we can focus on business side of the scalability, and we can focus on application development of our product or the service. So in short, platform as a service is a service that enables developers to build and work with applications without even having to worry about the infrastructure or management of the underlying hosting environments. And some examples of PaaS in Azure is SQL and Azure Storage. Talking about infrastructure as a service, IaaS, now this is moving down the stack even further. Now we get to the fundamental building block of the cloud service, which is infrastructure as a service, IaaS. Now IaaS is fully of highly automated, scalable computer resources. IaaS is full of storage. IaaS is full of the network capability. That's what IaaS is. Now, IaaS clients have direct access to the servers and storage, just as they would to do traditional servers. But in this case, it's going to be in the cloud. In this case, it's going to be more scalable. So IaaS is very similar to what you would do in your on-premises physical data center. But when we talk about IaaS, we get to do everything, but it's stored in the cloud. So if we need to build a definition around IaaS or infrastructure as a service provides users with components. It provides components. It does not give us a built environment. It simply provides a component such as operating system, networking capabilities, and a lot more. Now this is a paid for based on the usage and can be used to host applications. In other words, this is pay as you go type. The more you use, the more you pay. The less you use, the less you pay. And some of the examples of IaaS in Azure is virtual machine. That's a great example for IaaS, and VNets for networking. That's another good example for IaaS in Azure. Another common question in Azure interview is, what are the instance types offered by Azure? The main intention of this question is, how well have you understood the different offerings in Azure, and how well are you trained to pick the right offering for the right service? Now, one size does not fit all, and there are a lot of services in Azure that under the carpet it does the same thing, but depending on how different your requirement is, we'll have to pick the appropriate service. So this question, what are the different instance types offered by Azure, it's to test how well have you used the product and services available in Azure, and how well have you applied them for the given requirement. You shouldn't be provisioning more, you shouldn't be provisioning less at the same time. So it's kind of matching the right service to the right requirement. So what are the instance types offered by Azure? As you see in the list, we have general purpose, compute optimized, memory optimized, storage optimized GPU virtual machines and high performance compute virtual machines. Now, answering just the names won't be enough in an interview. You'll have to go further and explain why and in what scenario you would use general purpose and what are the use cases, what type of servers is a good fit for general purpose and what type is a good fit for compute optimized, so on and so forth. And that's exactly what we're going to do now. So the general purpose VMs, they provide a balanced CPU to memory ratio, and it's very good for testing, very good for a development environment, very good for small and medium databases, and also for low to medium traffic web servers. And some of the use cases are, like we said, test servers, low traffic web servers, small to medium databases, some enterprise grade applications. It's also good for relational database. It's also good for servers used for in-memory caching. It's also good for some small analytic database, very good for microservices. And if you're trying to build a proof of concept for an idea that you just have or just parked, this is another good server for doing proof of concepts, because you're not going to send actual traffic to it. I just want to show that your idea works. So general purpose server is a very good use case for those scenarios. And the largest instance size we can get in general purpose is standard D64 V3. Which comes with 256 gigabit of memory and 1600 gigabit of SSD temporary storage. On the other hand, compute optimized VMs have a high CPU to memory ratio and are very good for medium traffic web servers, very good for batch processing servers, very good for application servers. Now, because it's compute optimized and compute means CPU, it's an excellent choice for workloads that demand faster CPU but does not need as much memory or temporary storage virtual CPU. Some of the workloads that run very well on compute optimized are analytic workloads, gaming servers require more CPU, they run really well. Batch processing are some of the applications that can be placed in compute optimized, and by doing that we get the actual benefit of the compute optimized instance. And the largest instance size or the largest instance size type is standard F72's V2, and here we get 144 gigabit of memory and 576 gigabit of SSD temporary storage in compute optimized VMs. In the same lines, memory optimized VM, they offer high memory to CPU ratio and that are great for databases. Databases require more memory, so it's a great fit for a database, and it's a great fit for medium to large scale caches, applications that require in-memory analytics. So this memory optimized, memory is more, so it's very good for in-memory analytics applications. And the largest instance size we get here is standard M128M, and look at the gigabit of memory. It's 3892 gigabit of memory, and look at the temporary storage. It's 336 gigabit of temporary storage. On the same lines, storage optimized. Now I guess I don't have to explain to you what storage optimized is used for. You might have easily guessed looking at the flow. Yes, storage optimized VM offer high disk throughput and IO and are very ideal for big data, SQL, NoSQL databases, data warehousing servers, large transactional databases, and a lot more. And some of the examples of the applications that can be launched on storage optimized are Cassandra, MongoDB, Cloudera, Redis. These are some familiar applications that can get benefited when we run them on storage optimized. And one difference between storage optimized and the other servers are they are generally optimized to use the local disk on the node attached directly to the VM rather than using an durable disk, which is actually a remote disk space. Now what does this allow? This allows for greater input outputs per second or throughput for the workload. So that's what we get. A greater throughput, a greater input outputs per second is what we get when we use storage optimized. And the largest instance size available in storage optimized is standard L32S, and the memory is 256 gigabit. And look at the temporary storage. It's 5630 gigabit of temporary storage. GPU type VMs, easy to guess. GPU optimized VMs are specialized virtual machines available with multiple GPUs attached to them. Now these sizes are designed for, or these VMs are designed for compute intensive, graphic intensive visualization workloads that require a lot of graphical processing unit attached to it. So in short, these are virtual machines that specialize in heavy graphic rendering and video editing. It also helps with model training and interferencing with a standard ND24RS, which has 448 gigabit of memory and 2948 gigabit of temporary storage. And the last but not the least, but the best, is high performance compute or Azure H series virtual machines. Now they are the latest in high performance computing VMs and are aimed to handle workloads like batch processing, analytic, molecular modeling and fluid dynamics, a lot of complicated applications in this VM. And this is the fastest and powerful CPU virtual machine with optional high throughput interfaces. And the largest instance size that's available is a standard L32S, which comes with 224 gigabit of memory and 2000 gigabit of SSD temporary storage. And a third common question is, what are the deployment environments offered by Azure? There are two main deployment environments. One is the staging environment and the other one is the production environment. Now in staging environment, let's talk about staging first. So when you're deploying a web app or web app on Linux, you can deploy them to a separate slot instead of the default production slot when running them in standard premium or isolated app service plan tiers. Now the deployment slots are actually live app with their own host name. And at a later point, the staging environment can be swapped with the production environment. So why do we need a staging environment? What are the benefit of it? So the benefit of deploying our application to a non-production or staging environment, it provides a platform to validate changes to our application before it can be made live in the production environment. And in the staging environment, the app can be identified using the Azure's global unique identifier, also called as the GUID URL. And it's very similar to the production URL, except that it has a custom name in front of it that identifies it as the staging environment. And for production environment, this is the live production environment that's serving customers' requests, that's serving the customer content. Now it can be slightly different from the staging environment in a way that the URL that's used to identify the production environment, that's more of an DNS friendly name, like the name of the actual service.cloudapp.net. That way it differs. In case of staging environment, you have a custom name right before it, so the custom name and then the cloudapp.net, but in this case you get the direct service name as the name of the URL. So this is live production environment which receives and handles and serves customer traffic. Another commonly asked question in Azure is what are the advantages of scaling in Azure? The actual thought behind the question is to see how much have you understood scaling, how much have you seen and how much have you applied the scaling effect in the production environment and have received benefits in return. So let's talk about it. Advantages of scaling in Azure. Some of the advantages are we get the maximum application performance. Now auto scaling is a built-in feature for the cloud services, be it AWS, Azure, Google, and a couple of other cloud service providers. It's a built-in feature for a cloud service. A cloud service should be auto scalable. And that includes mobile services, virtual machines, and when we run our applications on mobile services or virtual machines, the website actually gets the best performance during the change in the demand. Again, different applications might require different performance needs. For example, for some apps, the performance is measured based on memory. And another good example is the fluctuating demand. For example, you could have a web app that handles millions of requests during the day and literally nothing at the night. And auto scaling this environment, auto scaling any of these environment will automatically scale or fatten your environment so to receive all the incoming traffic, and during lean period it actually gets slimmer and slimmer so to help you with the cost. So it actually maximizes the performance. That's what auto scaling does. And like we said, auto scaling scales up and scales down based on demand. It not only scales up but also scales down so to help you with the cost. And if you know the particular pattern in which the application is going to receive traffic, then we can very well go ahead and schedule scaling to our application or schedule scaling that infrastructure based on time. If we already know that Monday to Friday, that's the traffic that I would get, and it's a constant one. It's not a public facing, but it's an internal application. So I know all the 500 users or the 1,000 or the 5,000 users who will be using it. So at any given point, it's just 5,000 users. It's not going to go beyond that. And during Saturday and Sunday, literally nobody's going to be in office. So no load at all. So in that case, I pretty much know how the pattern is going to be. I can go for scheduled scaling if I know the pattern. And auto scaling, like I said, not only helps with keeping the application highly available, it also helps with the cost effectiveness of our infrastructure. So anytime there's a VM or a group of VMs running on less CPU, auto scaling is going to actually get the environment slimmer and slimmer, so we're not unnecessarily running any resources and paying for it. If you're being interviewed for the infra side in Azure, this is another common question that gets asked. How are Windows Active Directory and Azure Active Directory different? Let's talk about the Windows Active Directory first. The non-cloud Windows Active Directory the service was released along with Windows 2000 Server Edition, and this Active Directory is essentially a database that helps organizations to organize the users, organize the computers, and a lot more. It provides authentication and authorization to the applications. Not only to the applications but also to file servers, to printers, and a lot of other on-premises resources. That's what the basic non-cloud Active Directory does. On the other hand, the Azure Active Directory is not designed to manage web-based services. The Azure Active Directory, on the other hand, was designed to support web-based services that use REST API interfaces for Office 365, Salesforce.com, etc. Unlike the plain Active Directory, this uses a completely different protocol. So protocol-wise, it's different, and the services that it supports is quite different. Now, besides that, it also has a couple of other differences as well. And let's look at them. So the actual Active Directory or the Windows Actual Directory is a directory service that facilitates working with interconnected, complex, and different network resources in a very unified manner. On the other hand, Azure Active Directory is Microsoft's multi-tenant, cloud-based directory and identity management service. And the Windows Active Directory has 5 layers to store data, to store user details, and to issue the management certifications. On the other hand, Azure Active Directory integrates or compresses the 5 layers into just 2 layers. Here, Windows Active Directory works with on-premises servers like applications, file servers, and printers, etc. On the other hand, Azure Active Directory, it works on web-based services that use RESTful interfaces. If you're being hired for the development environment or for the cloud DevOps support environment, or even for the production support environment, you might find yourself being asked this question: what are the types of queues offered by Azure? Now, Azure supports 2 types of queue mechanisms, the storage queue and the service bus queue. Let's talk about storage queue first. Now, the storage queue, which are part of Azure storage infrastructure, it provides a simple REST-based interface, simple REST-based get, put, and peek interface. It provides reliable, persistent messaging within and between the services. It follows the pub-sub model or a pub-sub messaging infrastructure, and it's best suited for users that need to store more than 80 gigabyte of messages in the queue. It can provide logs for all the transactions executed against the user's queue. So that's what we get with storage queue. And on the other hand, service bus queue. The service bus queues are built on top of broader messaging infrastructure, and they are designed to integrate applications and applications component that can span multiple communication protocols. So that way it differs. So this is good for applications and components that may span multiple communication protocols and even totally different network environments. So in short, these service buses or the service bus queues in Azure are part of Azure's messaging infrastructure, and they integrate applications or application components that can actually span multiple different protocols and multiple different network environments. It also provides an first in first out style for delivery, and the user's queue size has to remain under 80 gigabit. Another familiar question is, what are the advantages of Azure Resource Manager? Now, the Resource Manager helps us to manage the usage of the application resources. This question is actually to test how well have you tested, how well have you used Resource Manager and have gotten the benefit of it. This question actually tests how easy it has become after the introduction of Resource Manager compared to when doing deployments or when provisioning resources without the Resource Manager. So let's get into the answers for the question. What are the advantages of Azure Resource Manager? In short, Resource Manager is called ARM. So the ARM helps deploy, manage and monitor all the resources for an application, a solution or a group. So all the interconnected application, all the interconnected services can be monitored as group using Resource Manager. And users can be granted to access to resources that they require within a Resource Manager. So in an account, I can have like 10 different resources created by a Resource Manager or a resource group created by Resource Managers, and I can allow deny connection to those services or only to those services based on whether the user should be accessing one and not accessing the other. So that way it becomes easy to give access to a group of application. It helps in getting billing details for the group of resources. Now, which group is using more, which group is using less, and which group has contributed more to this month's bill, stuff like that. So those details can be obtained using Azure Resource Manager. And provisioning resources is made much easier with the help of this Resource Manager. Another question is, how has integrating hybrid cloud been useful for Azure? Well, with the use of hybrid cloud, we get the best of both the worlds. So what's hybrid cloud? It's nothing but combining the public cloud and the private cloud and allowing data and applications to be shared between them. So whenever the compute or the processing demand fluctuates, hybrid cloud computing gives businesses the ability to seamlessly scale their on-premises infrastructure in the public cloud and handle any kind of overflow in the requirement or overflow in handling the application. So it really helps. It boosts the productivity of our on-premises application. So with the hybrid cloud, we get a greater efficiency with combination of Azure services, DevOps processes and tools for the application running in on-premises. And by having a hybrid cloud environment, users can take advantage of a constantly updated Azure service and other AWS marketplace applications for their on-premises environment. And the other benefit is with hybrid cloud environment, we can simply deploy applications regardless of its locations. In case of on-premises, we'll have to worry about the location, but when we expand our on-premises environment in the cloud, we can pick any of the locations and simply deploy it in them. And this enables the applications to be created at a greater speed. What's federating in Azure SQL? Now this question is very specific about SQL. How can we scale the SQL database? Now this is a very good question or a valid question or an important question in the interview, because many customers or companies have not been able to meet the user demand because they could not scale out the databases. The theory of scaling out or adding servers to accommodate the increased workloads and traffic is not hard to understand, but the implications can be very complicated. The implications can be very expensive. We're well aware of scaling the web servers, that's very common, but how do we scale the database? So Microsoft provides the tools and technologies so we can scale out the database in the cloud, and that's what is called SQL or federation in Azure SQL. So the way we scale out the SQL database is by sharding the database. So sharding actually enables users to take advantages of the resources in the cloud. Not only that, it allows users to have their own database or a shared database amongst each other. Because we're creating a highly available database, because we're having shards in a database, it actually reduces the possibility of a single point of failure for our database. And more importantly, because we're sharding, because we're using federation and Azure SQL, it provides an cost-effective scaling of our databases by using cloud resources or by using billing only for the cloud resources that we have used. So no pre-provisioning, no over-provisioning. It provisions the right amount and we pay the right amount. Let's talk about this one. What are the different types of storage offered by Azure? Now, the different types of storage offered by Azure are, as you already know, and as you can see, they are Azure blob storages, table storages, file storage, and queue storage. So let's expand one after the other. Now, blob storage are nothing but a massive scalable object storage, and that's very good for storing text and binary data. And Azure Blob Storage is Microsoft's object storage solution for the cloud. Now, blob storage is optimized for storing massive amount of unstructured data that can be in form of text or in form of binary data. So in short, blob storage enables users to store unstructured data, and those data can be in the format of pictures, music, video files, and a lot more. And it stores them along with their metadata. And another advantage or another feature benefit that we get from blob storage is when an object is changed, it is verified to ensure it is of the latest version, number one. And number two, it provides maximum flexibility to optimize the user's storage needs. And this unstructured data is available to customers through an URL or an REST-based object storage. So they are the benefits that come along with the blob storage. Table storage, on the other hand, is a NoSQL store for schema-less storage of secured data. Now, this Azure Table Storage is a service that stores structured NoSQL data in the cloud. And because this table is schema-less, it's very easy to save your data. It's very easy to adapt your data as the need for your application grows. And this table storage is very fast and cost-effective for many type of applications. So some of the type of data that we can store is table storage is good for flexible databases like user data for web applications, address book storage, device information storage, and if you want to store metadata, this is a very good use case to store them in Azure Table Storage. Azure Files is another storage. Here it's a managed file share for cloud or on-premises deployment. So file storage provides file sharing capabilities accessible by the server messaging block protocol, and this can be accessed from the cloud and this can be accessed from on-premises as well. Here in file storage, the data is protected by SMB 3.0 and HTTPS protocols. And the more important thing is Azure takes care of managing hardware and the operating system deployments for Azure file storage. So this additional file storage can be used when we want to burst the storage capacity in on-premises. So on-premises, the primary, and cloud is the secondary or the extended on-premises storage. So it actually improves the on-premises performance and capabilities for our on-premises data center. And then we have queues, Azure Queues. It's a messaging store for reliable messaging between the application components. So we spoke a little about this in the previous question. So the Azure Queue Storage is a service for storing a large amount of messages that can be accessed from anywhere in the world via HTTP or HTTPS protocol. In here, a single message can be up to 64 kilobits in size, and in a queue we can have millions of messages, and the limit can actually go up if we have not reached the limit of the storage account. So it's millions and millions of requests that can be stored in the storage queue or the queue storage. So the queue storage, in short, provides message queuing for large workloads, and it enables users to build flexible applications and separate the functions one from another, so one failing doesn't affect the other application which is running healthy. And this queue storage, it ensures the application is scalable and less prone to individual component failures because they are decoupled, separate now. It also helps in monitoring the queue, which ensures the customer's demands are met. So queue is a great place to monitor, or a great component to monitor, so we understand how much peak have we reached for a particular application, service, or a container. What is text analysis API in Azure Machine Learning? Now, text analysis is actually an cloud-based analytics API, and it provides an advanced natural language processing over the raw text. And it has got 4 main functions, like the sentiment analysis and the key phrase analysis, language deduction, and a few other things. Now, what do you mean by sentiment analysis? Now, sentiment analysis is from the logs, from the comments, from the text comments that we receive, do an analysis and find out whether that's a positive or a negative statement. Now, if it is the API returns an sentiment score between 0 and 1, and 1 is positive and 0 is negative. And then in text analysis, we have a key phrase extraction, which is it will automatically extract the key phrase to quickly identify the main points in that key phrase. For example, if you're analyzing an text which says the food was delicious and there were wonderful stuff, then the API returns the main talking points of that phrase, like food is the main talking point, and wonderful stuffs, that was a main talking point. So that's another feature that this text analysis has. And then we have language deduction in text analysis, right? Irrespective of what you paste, it can try to gauge and try to align it to the 120 or up to 120 languages that it supports. So I can simply take text from the internet and I can paste it, and text analysis software is going to identify the language and then can run phrase and sentiment analysis on those texts. Right. So in short, text analysis is an API, a set of web services that can be used for text analysis. It can be used to analyze unstructured statement, sentiment analysis, key phrase extraction, and a lot more. And the results are generally between 0 and 1, and 1 being positive and 0 being the negative sentiment. There is no much training, or in other words, this is not as complicated as a couple of other text analysis softwares are available in the market. We can simply paste, we can simply upload the text, and we can call the service and it runs a sentiment analysis on it all by itself. Let's look at this question. What are the advantages of Azure Queue Storage? If you're going to work in a development environment, if you're going to work in an environment that embraces DevOps, this could be a question. What are the advantages of Azure Queue Storage? Now, Azure Queue Storage is built to flexibly operate the applications and separate the functions between the applications that run large workloads. So when we design applications for scale, these applications can be decoupled so that they can scale independently. You know, a thing happening on an application is not dependent on another application, and anything happens to a section of the application will not affect the other application because they are now decoupled and connected through the queue storage. So the queue storage gives us asynchronous message queuing for communication between the applications, irrespective of whether they are running in the cloud or whether they are running in desktop or whether they are running on premises or on mobile devices. So in short, this queue storage enables message queuing for large workloads in a simple and cost-effective and a durable manner. Talking about the advantages is it provides rich client libraries for Java, Android, C++, PHP, Ruby, and a lot other services getting added during every new release from Azure. And the main advantage again is it enables users to build flexible apps and separate the functions for bigger or greater durability. Again, introduction of queues into our application, it ensures our users' applications are scalable and less prone to individual component failures, meaning one component failing is not going to take the whole application down. Right? If one component fails, it's just that component that fails. The rest are healthy and the rest are going to function. It also helps us to monitor the queues and ensure the servers aren't overwhelmed by sudden traffic bursts. So how much do I have in the queue? kind of determines the traffic for my application. And if the queue is more, I can always go and auto scale my environment, and the queue is less, I can always go and shrink or make my environment thinner so it can save cost. And anytime there is more data in the queue, I can auto scale, monitor the metric and do auto scaling based on that metric. So the environment knows that there are more data coming in. I need to expand myself to handle that much amount of data. This is a very common question. What are the two kinds of Azure Web Service roles? Now, a service role is a set of managed and load balanced virtual machines that work to perform some task. And based on what it's going to run on top of it, is it going to run a web service or is it going to run a worker service, defines what kind of roles that gets attached or that goes on this virtual machines. So we have two types, web role and worker roles. The web role is a cloud service role that's configured to run web applications developed on programming languages, technologies. And majorly they support IIS, Internet Information Service, and they support ASP.NET, PHP, Windows Communication Foundation, and so on. So that's web roles. And these web roles, it automatically deploys and hosts application through the user's IIS, Internet Information Service. On the other hand, worker roles are roles that runs applications and service level tasks which generally do not require IIS. So IIS is actually the differentiating factor. So in worker roles, IIS is not installed by default. The worker roles are mainly used to perform supporting background process along with web roles and do tasks automatically compressing or uploading the images, running scripts, and or doing some changes in the database, getting new messages from the queue and processing, and a lot more. The work, the applications, or the work that does not require IIS. That's what this worker role does. Again, the main difference between the web role and the worker role is that the web role automatically deploys and hosts your application through IIS, whereas the worker role does not use IIS and runs our application as standalone. This is another classic question. What is Azure Service Fabric? So Azure Service Fabric is actually a distributed system platform that makes it easy to pack, deploy, and manage scalable and reliable microservices and containers. Now, Service Fabric also addresses some of the significant challenges in developing and managing cloud-native applications. And the problem that it addresses and fixes is, now developers and administrators can avoid complex infrastructure problems and focus on implementing mission-critical and demanding workloads that can be scaled and that can be managed through the console or from the single place. In short, Service Fabric provides a platform that makes the process of developing microservices and managing application lifecycle a lot easier. And the advantages of Service Fabric is that now we can produce application with faster time to market because all the worry about the infrastructure is taken away from us. We don't have to design an infrastructure. All that we need to worry about is simply the application and the application lifecycle. Again, the advantage is it supports Windows, it supports Linux. Not only that, it supports servers on premises and in the cloud. With Service Fabric, we can scale up our environment to even 1,000 machines in just a single command. Or if there is an immediate need for 1,000 machines, I can immediately scale them up to 1,000 machines. That's possible with Service Fabric. Now let's look at this question. You can expect this question if the customer is running a hybrid environment, meaning having some of the applications in on-premises and running some of the applications from the cloud. And for some reason, when classifying the application that goes to the cloud and that stays on-premises, they have decided to keep the database in-house. So in that environment, a lot of customers do that. So in that environment, this is a classic and a scenario-based question. A client wants the front end of their application to be hosted on Azure in the cloud and wants the database to be hosted in on-premises for security reasons or to have full control on their databases. How do we go about suggesting a solution for this customer? The ideal solution in this scenario is to use the VNet-based point-to-site VPN solution. So all the front-end applications will be in the cloud and they'll be hosted in a VNet, and from the VNet they'll be connecting to the database through an point-to-site VPN. So the traffic and the writings and the reads are not coming through the internet, but through a point-to-site VPN link that's connecting the Azure VNet and the on-premises environment. And this model or this approach or this solution is best suited for scenarios where there are only a limited number of resources that needs to be connected between on-premises and the cloud. This is a very common question. What's Azure Traffic Manager? Of course, we no more running applications on a single server. We no more running applications on or from a single environment. Right? The same application is being run from multiple environments within Azure, and it can be running from Azure and on-premise as well. So multiple environments between Azure and on-premises. And a lot of customers have such environment. And if you're facing an interview with such customer, this could be an ideal question. What is Azure Traffic Manager? Now, the Azure Traffic Manager is a DNS-based traffic load balancer that actually enables us to distribute traffic between services across Azure global regions. And by doing this, it provides a good availability and a good responsiveness to the application. And this traffic manager, it uses DNS to direct client requests to the most appropriate service endpoint based on the traffic routing logic and the health of the endpoints that it maintains. So in short, this traffic manager is a load balancer that enables users to provide high availability and responsiveness by distributing traffic in an optimal manner across the Azure when we run the same application in different regions. So some of the advantages or some of the use cases of using Azure Traffic Manager is it provides multiple automatic failover options. It also helps with reduced downtime. It also helps with the distribution of user traffic across multiple locations. So one location is not overloaded. And then it helps with users knowing from where our customers are getting connected from. That's another big use case with Azure Traffic Manager. Let's look at this question. Right, this is an ideal question. Now there are a group of servers connected together within an virtual network, and now we need to move them or create a separation between them. How do you go about achieving it? So the question goes like this. You need to isolate network traffic among VMs in a subnet, which is part of a virtual network with little downtime and impact on the user. So that's the given scenario. And the best way we can do it is create a new virtual network and move all the VMs in that subnet to the new virtual network. Now, this feature is not possible with a lot of other cloud service providers like AWS and a lot of other providers. Now, in those environments, we might need to shut down, we might need to stop the VM, create a new VM based on the image, and it's an hefty process. But here in Azure, I can simply move the VMs from one subnet to another virtual network without needing for any additional security like the network security group. I can simply isolate them if I need to by creating a simple new virtual network and moving the servers to the new virtual network. Look at this one. This is another common question. With respect to Azure, what is public, private, and hybrid cloud? So this is really to test how well have you understood the different cloud offerings in the market, public, private, and hybrid, or at least the three basic offerings in the market, public, private, and hybrid cloud. Now, the public cloud is the most common way of deploying cloud computing applications, and it has resources like servers, storage, and are owned and operated by third-party cloud service providers like Microsoft Azure. Microsoft Azure is a very good example of public cloud. So here, every component that the user is using is running only on Azure. That's public cloud. Right, let me talk to you about some of the advantages of public cloud. Some of the advantages is low cost because there's no need to purchase hardware or software, and we pay only for the services that we use in public cloud. And there is literally no maintenance because the service provider maintains the environment for us. And with public cloud, we have nearly unlimited scalability, meaning we can get resources on demand and can meet our business requirements on demand. And the public clouds are very highly reliable because they have a vast network of servers and they ensure that our application does not fail. So there are some advantages of public cloud. Let's talk about private cloud. Now, private cloud consists of compute resources used extensively by one business or one organization. Now, this private cloud can be physically located at our organization's on-site data center, or it can be hosted by a third-party service provider. Whichever the case, the private cloud services and infrastructure are always maintained on a private network, and they're maintained on hardware and software that are dedicated solely for one organization or solely for your organization. So in short, private cloud in Azure is Azure services being run within an on-premises data center or on-premises data center used by the user to host systems or applications. And some of the advantages is it gives more security. Resources are not shared with others, so a higher level of control and security over our resource and application is possible. And then we have hybrid cloud. Now, hybrid cloud is the best of both worlds. So it combines the features of both public and private cloud. And some of the user components are being run on Azure and others within on-premises data center. So they kind of share the resources. In other words, they kind of share the application. Half of the application would be running in on-premises and half of them would be in the cloud, and they would be working in harmony to support the application and the business need. So that's hybrid cloud. This is another good example question that wants to test how well you pick services, or how well have you understood the Azure products and services and are picking the right service for the need. So the question would go like this: what kind of storage is best suited to handle unstructured data? There are a lot of storage options available, and the requirement here is what or which one would you choose for unstructured data? The answer for that question is blob storage, because blob storage is designed to support unstructured data. It works in this way. It places the data into different tiers based on how often they are accessed. Different tier means different performance. Different performance means different cost associated with it. So a lot of add-on advantages will we get when we use blob storage for unstructured data. In addition to it, any type of unstructured data can be stored in blob storage. This is not true with a couple of other storage options that we have in Azure. Only with blob storage we can store any type of unstructured data. And the data integrity is maintained every time an object is changed in the blob storage. And the best part is the blob storage helps increase applications performance and reduces the bandwidth consumption for that application. So they are the benefits that we get for blob storage, and blob storage are the ones that are well suited for unstructured data, and that's what your answer should be. It's really an 5-step process, and if you have worked and if we have done some basic labs with Azure, you can easily answer this question. So it's a 5-step process. First step is to log into the Azure. The second one is to create an resource or a resource manager. And within the resource manager, you would be selecting the resource. And then pick the operating system. Do you want Windows or Linux? And within Windows, what's the flavor you want? Or within Linux, what's the flavor you want? So decide on it. And then entering the relevant information like the name of the instance or the VM that we're going to launch, and the password, the URL that goes with it, and a couple of other relevant information that gets itself attached with the VM. And then select the size of the virtual machine. Different size, different types available for the kind of application and for the intensity of the application that will be running on top of it. So select the size of the virtual machine, review everything, whether they're good or not. If there are any changes required, go back and edit them, and then come back and launch, and your VM is there for you to start working within like 3 or 4 minutes, not even 5 minutes. Within 3 or 4 minutes, it gets ready and you can start working on it. So it's a quick and it's a 5-step process, and you should be able to answer it easily if you have done a few labs in Azure. Let's now look at some scenario-based question. You've been posed with a scenario. So we thought through it and we picked some common scenario-based questions that are being asked in an interview, and I thought we'll present it for you with the answers, with explanation, so you can get benefited through it. So let's look at this question. You're asked to make sure your virtual machines are able to communicate securely with each other to ensure security, or to have good amount of security. What would you do? And the correct and the best answer for this would be using virtual network in Azure, which enables us to communicate with the internet securely, which enables us to communicate with the on-premises data center in a secure fashion. So the advantage of using virtual network is users can create their own private network, users can pick their own private IP ranges, users can create their own subnet, users can create their own routing between those two subnets. A lot more goes into that virtual network. So it's very customizable, and the users are provided with an isolated and highly secure environment for applications. It's completely isolated from other customers, it's completely isolated from other applications that are running in other virtual network that we own. So within our account we can have multiple virtual networks, and one application running on a virtual machine is completely isolated from other applications running on other virtual machines. And of course all traffic stays within the Azure network, Azure virtual machine, or within the Azure network, depending on how you set up the routing. If you have set up a routing to go or reach the internet, it's going to go, otherwise it's going to stay within Azure. If you have set up routing to reach on premises, then it's going to go and reach on premises, otherwise it's not going to go and reach on premises, it's going to stay within the Azure. And it also allows users to design their own network, like we already discussed, picking up IPs, picking routing, picking subnets, how many servers should be present in that particular subnet, or how many servers should that subnet accommodate, the size of the subnet, the IP ranges, the NATing, the masking of IPs, creating of VPN, all that's possible with the virtual network. So it really allows users to design their own network, and using virtual machine is how we secure applications in the cloud. Let's look at this other scenario. How do you ensure that every time a user logs in, they are not asked to re-enter the password as part of authentication? So you really don't want your users to re-enter the password every time they log in to a different application. Well, all the applications have their authentication mechanism in place. All of them wants to authenticate the user before they log in. Ensuring the user does not log in every time does not mean that wiping away all the authentication and authorization that's present in that application. You still need that in place, but how do you make the user hassle-free so they're not asked to re-enter the password or the same password again and again? Let's look at the options available. The first one is to enable Microsoft account authentication. Well, it's not going to fix, because with that the user will still need to re-enter the username and password. Deploy express route. It's not going to fix either, because express route is a network level service that connects on premises to the cloud. So that has got nothing to do with prompting or not prompting for password. And then we have set up VPN between on-premises data center and Azure, set up AD domain controller in VM, and implement integrated Windows authentication. Well, you can use the same username and password for on-premises and the cloud, but this setup, the VPN and the AD controller setup, it's not going to stop you asking for repeated passwords. So this is all about using the same password in on-premises and in the cloud, and this has got nothing to do with not prompting the user to re-enter the password. Alright, so that's same password is different from not prompting the user to re-enter the password. They are two different scenarios, so that is also out of the equation. And the last one is configure AD sync to use single sign-on. That's the right one. So when we configure the AD to use single sign-on, then it's not going to ask for the username and password every time we access an application, because we have logged in, and that login is going to stay active for like 24 hours or so, depending on how you configure it. And within that time you can access a lot of other applications, and it's not going to ask for the username and password, because you already have a single signed on and you have signed in using the right credentials. Let's look at this one. You need to ensure that virtual machines remain available while migrating to Azure. What would be the appropriate service to use? Right, let's look at the options. Traffic Manager. Traffic Manager is literally an DNS service. And then let's look at the other one, Update Domains. It again has to do with Traffic Manager, updating the URL. So the Traffic Manager gets updated and then starts sending requests to that particular URL. It's going to take some downtime, because when we update the URL, they will have to be populated to all different places, and it takes time. So within that time, any user trying to access, it's going to fail. And then we have Express Route and Cloud Services. Express route could be in fact, it's the right answer because express route, it's an extension of our on-premises and cloud environment. And in this question, it really comes out from a customer who's having an hybrid environment. So they have applications running in on-premises, they have applications running in the cloud, and they want to have a way to migrate applications from on-premises to the cloud. In other words, kind of do a cutover between on-premises and the cloud. And this express route is a service that connects between on-premises and the cloud. So when you do the cutover, the traffic is now sent to the cloud instead of being handled in on-premises. In fact, the services and the application is getting shut down in on-premises. So the request will come in the same pattern. Instead of they being handled in on-premises, they are now routed to the cloud using express route, and the API calls get addressed or the queries gets answered in the cloud through the express route service. Look at this question. You are an administrator for a website called WebGame, and you are required to validate and deploy changes made to your website by your development team with minimum downtime. So the real question is, how do you validate the deployment changes that's made by the development team? Let's look at the options. Create a new linked resource, create a staging environment for the site, enable remote debugging on the website, and then create a new website. Well, why would you want to create a new website? Just to validate the changes. And doing a remote debugging is not going to help because debugging only captures logs of the changes happening. It does not do anything with validating the changes. Create a staging environment could be or is the right answer, because when we have staging environments, anything that we run on production can be run on staging environment, and any failures that would happen in production, if we simply run it in production, can be captured when we run the application in the staging environment. So that way, staging environment is a very helpful and useful service, and that way I can catch any errors. In other words, I can validate the changes that were done by my development team before I move it to production, and that reduces the downtime in the production environment. Look at this one last question that we have for you. It's a standard tier application is used across the world and uses Azure Website Standard Tier. It uses large amount of image files, so you can get it. This could be an e-commerce website which has a lot of pictures in it, and this is causing the application to load slow. How can we handle this situation? Let's look at the options given. Configure blob storage with custom domain. Well, this application has pictures, but only the pictures is not all that the application has, right? So configuring blob storage might not help. This could be an very interactive website and that can't be run from blob storage. Let's look at the other options. Configure Azure Website Auto Scaling to increase instances at high loads. Now, it's the picture that's causing issues for the website. It's not the CPU or it's not the memory unavailable, memory not enough, that's causing the application to be slow. So we need to identify what's causing the application to be slow. So it's not the CPU, it's not the memory. So configure Azure for auto scaling is not going to help. And then what are the other options? Let's see. Configure Azure CDN to cache all responses from the application's web endpoint. A CDN could be the right answer, but look at that. It says a CDN to cache all responses from the application's web endpoint. CDN is not designed for that. Though it can do it, that's not the best way to use CDN to capture all responses from the application's web endpoint. The proper design for CDN would be to cache the frequently used ones. In other words, cache the static content, which are photos, videos, logos, and pictures, and a lot more. Static content that never changes. Let's look at the last option. Configure Azure CDN to cache site images and content stored in Azure Blob Storage. Absolutely correct. So here we will have to redesign the application to store the pictures, high quality, lazy loading or slow loading pictures, because of the high quality and the bigger size. So store them in CDN, and then the content, let it be stored in Azure Blob Storage. That's the right way of designing the application, and if we do it, this application is going to run faster, or the application is going to respond faster to the users.
And with that, we have come to the end of this video. I hope it was informative and interesting. If you have any questions about the topics covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.